Okay. Are we live? Are we live? Is this running already? Can I place this here? Why am I screaming so loud? I don't know. I feel the hype today. Because I'm prepared. Can you believe it? I have... Oh my goodness! Can't... Wait. Okay, all fine. What did you guys just see? What happened there? Anyways, let's go! I'm so prepared. I have my screen already installed. That's amazing. So let's connect to lgl.zillyhoon.com. You might be wondering, what is this weird letter combination? LGL stands for Lasergurkenland. And Gurken is essentially German for cucumber. So it's Cucumberland, right? And Zillyhoon, I'm not going to explain that one because that's a privacy secret and stuff like that. If you knew, I had to kill you. Anyways, so lgl.zillyhoon.com, join now for free, fuck's sake. And it's Anarchy, so you're allowed to do whatever you want. So you don't pay anything, and you're not limited by anything whatsoever in terms of moderation. So there's no administrator maintainer that is above you and feels superior. You can be the greatest motherfucker in this environment and essentially take it over. If that is appealing to you, go and join and please donate. Well, actually, I'm not even depending on donations because I paid the server in advance for multiple years already, and I made sure that I have enough disk space, currently running with 190 gigabyte of world space, so that's performing well so far. Backups tend to have a downtime, but that's fine, I guess. Anyways, so if you are interested in playing here, please do so. Since currently we are still hosting it locally, and by we I mean me, there's essentially nobody else running the server, and that sounds a bit newbie and so on, but I also have a server in a data center, of course. I currently just did a local backup of the world and copied it to my own hard drive, where I can then you know, further back it up and move it around when I move the server back into the cloud again. Well, let's not call it cloud. Into the data center. Let's call it like that. Anyways, so, and also another reason is it's vanilla. It's performing bad, so I'm testing how well it runs with my hardware, and maybe if I have to complain at my data center provider to increase my performance. I'm currently running on, oh yikers, I actually don't know the specs of my local machine here. It's not too bad, not too good. It's should I quickly look it up actually, just for you guys? Maybe you might be interested. I'm gonna flex my specs, and we have a Intel i7 6700 HQ with 8 cores at 3.5 gigahertz. I guess the graphic card doesn't matter, right? It does not run on the graphics card. And yeah, the Minecraft processor is currently assigned 20 gigabytes of RAM. And on the production server, I forgot to, well, it's a, wait, is the stream even running? Usually I check before I talk forever. Oh, the stream is running. Awesome. Okay, cool. Awesome. Anyways, so in production we only run with, why do I call it production? This is also, I'm using these weird terms. Whatever. Like usually in the data center, in the server that I paid multiple years in advance already, that has like tons of disk space and so on. There I run only with 16 gigabytes, and a shared CPU with like a zillion cores at a solid clock speed. So yeah, well, of course, Minecraft itself bottlenecks itself pretty well. So that's that. But Jesus. Okay, you know, I had to do some business texting. You know, I'm such a businessman. Anyways, let's go. Anything left to say for advertisement purposes? Oh my gosh. Oh my fucking... Why does it always happen? I thought my base is safe. Let me grab these precious shulkers. And can we start this machine? Yeah, there's no TNT. That's too bad. Oh my goodness, it's always happening. If you don't play fast and focused, you mess things up. Oh my god. How did, like, what even happened here? Am I in a machine that is not dropping TNT? Oh, I am. Yeah, whatever. Anyways, so... let me think. All right. Yeah, I usually don't have my phone sounds activated, like never, but I have to do some business, guys. So that's that. It sucks. Anyways, do I have to dupe today? No, I don't. Let me get something to drink and let's get started, boys. Let's get started. You might be interested in what I'm drinking. Well, probably actually you are not, but I'm not going to tell you anyways. Because that's highly private. It's inside a glass bottle though, so that's that. Well, most liquid can be filled into glass bottles, can't it? Anyways, let's go get started. I didn't even prepare a video, but I prepared a screen, so that's more than enough probably. Let's go to Hussein Nasser, and I still can't pronounce his name, going on, guy? Even though I'm like already his main fan base. All my software engineering content. Oh, we gotta watch that video because I feel like literally it's addressed to me. I don't know. It's a video from like today, something like that. 680 views. All my software engineering content is now on the Creative Commons license. Let's quickly peek into that. Let's go. We love that. Do you know what that means? That we can watch these videos in this stream and feel a little bit safer on the legal side of things. I love it. I love it. Okay. Yeah, let's not put that in the title yet. Well, we can, no, let's not put it in the stream title yet, but in the description. Awesome. So check out the channel that I linked in the description, and let's get started.
The other day, someone left a comment on my YouTube channel.
That was me! Hi! I'm featured in this video. I don't know why I'm so excited. I didn't even know this guy when I was writing this video, this comment. So I became a fan of this guy after I'm like buddies with him. Okay, now I'm exaggerating a bit, but anyways, let's go.
Asking, hey Hussein, I love your content. I love that you talk about software engineering and software news and backend engineering technologies, and I really appreciate that.
Did I write it like that, or is he referring to another comment, or is he like inventing? Okay, anyways,
However,
it's the freedom of an artist, isn't it?
I wish I could stream and commentate on your content.
Stream? Well, that's maybe me, might be me. Who else would be streaming his content? Oh, no front. Yikers! I don't know why I think this is so funny. Anyways, let's go.
So I was like a little bit surprised about that comment. So I replied back and said, why couldn't you live stream on Twitch or YouTube or anywhere?
Wait, he did. No. Wait, let me search this comment now. How do I find this comment? It might leak my secret identity if you find this comment, so please don't search it to protect my privacy. But how do I find comments I wrote? I have my notifications since he responded. I can search for that. Okay, here. Let me see. Like he said that someone said how cool his videos are and he wants to stream the content. Oh, I actually mentioned streaming. Okay, interesting. But I didn't comment on his content because I literally never watched his content when I wrote this comment. That's the best thing. And he said that he responded with a question, but he didn't respond with a question. He just said, yes, you can use my stuff.
And commentate on my content. Like, you can absolutely do that. You can criticize me. You can say the thing I say wrong. You can.
Awesome, I can criticize him. I love that. I tend to accidentally front people. That's awesome. Cool. No hate, by the way.
Say that I disagree with your opinions on this particular thing.
I did actually disagree with some like of his term bashing already, so that's that.
Technology, or I don't like your opinions about HTTP2 versus WebSockets. You can absolutely do that. So I was like, why? He said, yeah, because you had your YouTube license as a standard license, not Creative Commons. I was like, what the heck is the difference between the two? I didn't touch any of that stuff.
Yeah, default is.
And there it is. I've been publishing content for 4 years now. Right now. Wait a second. 2014, 2015, early 2015.
Yeah, it's an
5
unknown
years.
setting.
All of this content, more than 500 videos. All of them are standard because that's the default for YouTube.
And you can change it after the fact.
At all. I just completely forgot about it. So, fair enough. I went there and updated all my content.
Wait, you can update?
So
I didn't know that.
Use the license Creative Commons, and you might say,
I thought
what's the
that's
difference between
impossible.
the two? So, in a nutshell, Creative Commons license allows people to kind of grab portion of your content or even all of it and convert it or transform it,
or not transform it and take the whole content. Do you know the channel Coding Tech? That guy is a genius. He just he takes every Creative Commons tech talk he finds and probably likes my I don't know if he has some filtering, and slaps a thumbnail on it and uploads it on his own channel. And then tuning in all the YouTube ads and getting money rich from content of other people. That's crazy. Like literally just re-uploading videos that already exist. Nothing else. No modification whatsoever. And that's crazy. And I don't know. I think it's a little bit weird. I would do it myself if I get money from it. Fuck it, I would do it. I'm just saying. It's like, if you think about it, it's just duplicating content. That is a bit weird. Of course, it has this aspect of sorting. So or like picking videos to watch. So you can subscribe to their channel, and he will pick tech talks for you that you can watch. Especially for me, for example, I could scroll through there, and I could also watch all these videos in my streams because they are all under Creative Commons. So that's a collection of Creative Commons talks. So it has some value you can see there, but it is a bit weird to just take other people's work, re-upload it, rebrand it with their own thumbnail, and it's a bit weird. It's called Coding Tech. Yeah, shout out. I probably shouldn't credit that guy. That bastard. Yeah, no hate. I totally I'm fine with that. If I would get, as I already said, if I would get money out of something like that, I would do it for sure. Okay, let's continue.
Size it and use it in fair use creation. So without that,
whatever fair use is,
standard one, you own the content and nobody can touch it, nobody can comment on it, nobody can do this, which is the opposite of what I'm trying to do. So guys, if you ever seen this, now is your opportunity. You can take any portion of any videos that I have on YouTube and feel freely to criticize. You can go ahead and cut and commentate on some of my opinions that I throw in this channel. You can do any of that stuff. You can live stream on this and use my content until your heart can. You can use my slides and you can use my videos to teach somewhere else. Feel free to do any of that stuff, as long as it's not just straight re-upload. Obviously, that's just that doesn't have any transformative value. So as long as you add value to the content in any shape or form, I am very, very happy to hear these opinions, because that's the purpose of free speech, and the idea of us creative persons to build on top of each other's work. So I have my work, I have my body of work, over 500 videos on backend engineers and software engineering, general software engineering content. I have a little bit of tutorials as well. And most of these are my personal opinion. And obviously you have the full right to criticize, commentate, agree or disagree with any of these things. That's how we build on each other, because how else can we learn and build on each other without this concept? So I'm really surprised that this option is not the default option. And then why would you have your videos up?
Well, because that's usually also, I don't know, I think especially in German, I don't know about other countries' laws. Essentially I don't know shit about law at all, but it's usually that the creator holds all rights by default. And if you don't know shit about licensing and you don't license, you own all the stuff, which sounds a bit rough. And if you walk around in the world, you cannot take anything from other people because it's all licensed and you don't have any permission to do anything in this world, theoretically. But practically, nobody's gonna sue you. But it just protects creators if by default they own all the rights. I think it's fine, and a little bit more awareness and Something like that could already solve the issue that people just actively choose to use more permissive licenses for their work. Yeah, I don't know. I think it's actually fine. Maybe on YouTube you expect that you can react to every video, which also is the case, but maybe some YouTubers don't want that and they want to like not have their content shared, or they want to delete their content again and they want to have the reactions removed or something like that. And if they give up on their permissions or ownership on the content, they lose that ability. So it makes somewhat sense that by default you're on the safe side. Sounds fair to me. But sure, it feels like YouTube is the other way around, but it isn't. But yeah, it's fine because it. The thing is, most people are like that Hussein, whatever, I can't pronounce his name, and they don't know about the setting. But if you watch their content, that guy won't come to me and sue me and fuck me and my family and block all my videos and delete my channel or something like that. That's a nice guy, and there are many other nice guys on the internet, and they let you react to your content. But of course you would be on the safer legal side if you have somewhat written permission by the license. But yeah, whatever. I think it's fine by default.
There, if nobody can change on top of that and criticize it.
Well, people can, but they have to fear that you are going to fuck them.
Contribute to each other. So guys, now as of, I guess, last week, all of my videos, I just used the mass update feature on YouTube to change all of this content to...
Especially if you have quality like feedback or respond to something, nobody would ever think of anything bad and be like, you don't have to use that, you're not allowed, whatever. Which rarely is the case, sure, but mostly not. But in my case, like, I'm not adding any value. I don't even show his video. It just sometimes looks like I'm talking the stuff where I'm playing the game. So like I'm totally I'm worse than Coding Tag essentially, and I'm not even making money of it. So I'm just a rude fucker. But well, for me it's just for my own personal entertainment, and that's why I want to be on the safe side. Yeah. Well. Okay, let's go. So that's this video.
Creative Commons, so feel free to use any of my content until your hard content. Feel free to commentate, share to your YouTube videos. Obviously, as long as you transform that, I'm very, very happy to see that. Thank you so much.
Oh my gosh, he said as long as you transform that. I was about to close the video already, and now he drops that bomb. I have to transform the videos. Oh my gosh. Oh my gosh, that guy doesn't know about Coding Tag for sure. Oh my gosh, we should probably warn him that now that he's running in the Creative Commons, Coding Tag might be slurping around the edge and looking at his content already, preparing some thumbnails and ready for the re-upload. And also, I'm not modifying his content essentially. Well, I removed the video from it, so let's call it transformed. Anyways, what is going on here? I'm a bit scared. He seemed a bit serious about the you have to transform the content part. That's essentially what Creative Commons protects you from. Yikes. Whatever. That guy's never gonna finding my streams here, so I have 0 viewers, and the re-upload also has 2 viewers, me, my cat, and my mom. And my cat has no YouTube account, so the view doesn't even count, and whatever. So, yeah, that's that. What the fuck?
It's just a quick update to tell you about that option. Thank you.
Should we let him know that the transform part is not a thing? Did anyone tell him in the comments? Yeah, no, I'm not going to. I don't know. No, yeah, I don't feel like writing a comment right now. I'm sorry. Okay, let's check out more of his videos and let's see, guys. Let's see. Diagnose your back. There was this 1-2 hour video that I wanted to watch. Which one was it? Let me quickly spin up my crazy content filtering. Filter short YouTube videos shorter than 45 minutes. All right. Here, RabbitMQ 2 hours. Crash course, Node.js, pros, cons.
What's going on, guys? This is a...
What's the format of this? Is he
I'm willing to
mostly
wait,
talking?
Content, that's it.
Awesome. He's not coding or shit, so that's something that is really easy on the ears. And it's 2.5 hours. Guys, let's get right into it. So, in Wireshark and more... Oh my gosh, this title is like, what is going on here? Okay, so what are we going to chop off? 2 hours RabbitMQ course. Okay, so we cut off the 2 hours. We call it RabbitMQ course with Node.js pros and cons, Cloud RMQ versus Kafka, RMQ and Wireshark and more. What about we chop all of that off and we call it RabbitMQ course with Node and Node.js pros and con. It sounds about fair. Then we put the title in our description and then we put the link to his video in the description. Oh my goodness, let's get started, guys. Are you excited? That's a long video. Oh, I still have to do some business, guys. I'm sorry, man. Okay, let me quickly mute myself. Alrighty. Guys, are you excited? Because I am. Let's go. Should we dupe? That's really a duping video, actually. Like, that's something where you can actually listen to the content and understand it while you're focused on something else. And if this something else is super boring, then that's big fun time. I don't know. Yeah, let's not. Let's just drive these machines back and forth instead. Oh wait, how do I, like, on this side I have to build it a little different, right? Can I revive any of these machines? Is any of these machines not completely broken? That one looks good. Okay. That one looks good. Good. Oh my gosh, where does it end? Oh my goodness. That looks a little messed up. Okay. And I see a creeper sneaking up on me already. What the heck? Okay, so these are these blocks, so those are important. Nice. Okay. We should probably remove those here so that I don't blow up myself. And let's check the other side first. Yeah, I can also probably remove some water and lava and shit. Okay, let's get right into the video, I would say.
What's going on, guys? This is a collection of my popular RabbitMQ content.
Oh, a collection.
On YouTube. So I'm going to discuss RabbitMQ as a technology. I'm going to show you a little bit of my deep discussions of RabbitMQ as a technology, my pros and cons, what I think is good, what I think is bad about RabbitMQ. Then we're going to dive deep into some sort of philosophical discussions of what RabbitMQ can evolve into, like can you implement like quick technology in RabbitMQ or something like HTTP2, multiplexing instead of having their own custom channel idea, their TCP, right? So a lot more discussion there. And I'm gonna dive a little bit deep into how RabbitMQ works today under the hood by doing a little bit of Wiresharking.
Awesome.
That protocol, the advanced message queue protocol, and see how it looks like, how chatty it is, how consumer consumes, and how publisher actually pops up queues, all that jazz, and talk about all that stuff. So if you're interested, check out this content. And
I definitely am.
The next one, check out the other content of this channel. I discuss anything backend engineering. That's what I love to discuss. I'm gonna see you in the next one. Enjoy.
I will.
What is going on, guys? My name is Hussein, and this video I want to discuss queues and when to use the queues, message queues to be specific. Like there are other type of queues, but I'm not sure what are they. So I'm talking about RabbitMQ, ZeroMQ, Kafka. When do you want to use this in your architecture, and do you really need it, right? And that's the question here. You always have a question that, hey, do I really need to implement this in my system design or not? And I'm just trying to kind of assess that and help you with that if possible. So how about we jump into it? And if you're new here, guys, I discuss all sorts of backend engineering in this channel. So if you're interested, subscribe and like this video and share with your friends. That's it. Let's just jump into it.
Oh my gosh, what is this sound?
What is a queue and when do we need it?
Can you hear it?
And, guys, if you
I hope you can.
already subscribe to my channel, you would see me repeat this over and over again. Any technology out there, any backend technology out there, it exists for a reason, and it exists to solve a problem. So I know that might sound cliche and makes just perfect sense, right? Yeah, of course, it exists for a reason. And that also means that there's no technology just exists for fun of it or because it's cool, right? You need to use it if that problem exists for you. You cannot just use gRPC because it's hip and cool, right? No, you should use it when you absolutely, the problems that gRPC addresses solve your problem,
Hex,
right?
man.
Addresses your problem. Same thing with the queue. So how about we talk about the actual problems with the queue solve? Back to the request response architecture. When I make a request to a backend, and regardless of the communication protocol that I use, whether it's TCP, stateful TCP, route, or whether I'm using gRPC, again stateful, or whether
I dropped my X in there.
REST architecture, that request requires some resources at the backend to be served, right? To be consumed and executed that request. What does that mean? It means that request might be list to get all the employees, right? Or an update to do a booking system, right? It's like, hey, I want to book this seat. That's the same thing, right? And this requires a finite amount of time of your server to actually process this. And we talked about the ways you can serve your request. And one way
Oh my gosh, this is
to
deep.
solve this problem is asynchronous execution with a single thread. Like your server has one thread, and that thread just keeps working the problems that it has, right? So serving a request, this is now listening to TCP connection, this is now doing that. That's how NodeJS does it, right? Other web servers does it differently. Multi-threading, multi-processing, right? Regardless, right? So Apache does multi-threading, Node.js does a single thread, but it's asynchronous. And we talked about that. I'm going to reference the video here. I think it's here.
Oh, I'm actually interested in that one, but yeah.
Sometimes a
watch this
single
first.
thread in a Node.js or multi-processing or multi-threading in a web server could not cut it, because you will quickly overwhelm that single server to execute all these requests, right? And it really depends if that request is taking a long time to process. And if it does that, if that request is taking a huge amount of time, an unpredictable amount of time to process, then there are flood of other requests that is coming. I'm not talking about queues yet, guys, right? Just normal request response. There are flood of requests coming, and they are waiting. And when I say waiting, the client is actually just blocked because that access to the TCP connection didn't even get a response back. Okay, and that could be harmful for the user experience, right? The user will feel it. Ooh, what is going on? I click and nothing happened. And users hate that. When they click and nothing happens, you show me something that happens, or tell me that something is happening, but don't tell me that I'm doing something and I did something and I don't see any result.
Oh no, that was stupid.
You're a user, you probably seen that. So how do we trick that? A normal request response architecture doesn't cut it in this case. If your response time is unpredictable, right? Because you have a lot of requests coming, and you might say, hey, Hussein, I'm going to scale horizontally, and that's absolutely fine. You can do that. You can put a reverse proxy, have it configured to be a load balancer, and swizzle the request to all services. And if you start seeing requests taking a long time to process, right, then you start spinning up more services, containers if you're on a microservices.
Oh my gosh, I almost dropped it.
And people do this to this day without a queue, without the idea of a queue, right? And as I said, this doesn't really scale well if your processing in the backend is very hungry, processing hungry, or CPU hungry, or RAM hungry, because you cannot spend a long time just having this process take time. So if you're predicting that responses will always take a long time, probably spinning up multiple services will not help you, right? Because the request will be the same, whether it's going sending to another server which is free, or a service that is doing other things as well. Yeah, you're gonna still see some minuscule. Is that the right word? Minuscule difference, but still, it's gonna take a long time. Here's where a queue is useful. If you really think that request will always exponentially go large, yeah, maybe if your database doesn't have any rows, but as you grow large, that request will go slower and slower and slower. It's just exponentially, not necessarily exponentially, just polynomially with your number of rows. So here's where queue really beneficial. So what you would do in this case is, here's what I'm gonna do. I'm gonna employ a queue in my system, a message queue. And that means if I am receiving a request to server, I will do a very quick operation that is constant. That is a big O of 1. It's a very fast operation. And I'm gonna respond to the user with some sort of an identifier, right? And that's how it works. So if I send me a request, I'm gonna put it in a queue. That's a
big off one because writing is always fast, especially if you're in a LSM3 kind of a database, right? And most databases now, especially write only, just write to the end, LSM, right? Non-structured memory. Right,
What?
and you respond back to the user, hey, I committed to you, user, that I have received your request. And it's now processing. Or it's in the queue. I can't promise anything else, but hey, I received it. Better than having a request that is not served, right? That is not just waiting. So check user experience better, right? Okay, I'm willing to wait as a user. Yeah, at least they received it. And now, really up to you as an architect. You can have the client come back and ask and poll, P-O-L-L, this task ID that we're given. Say, hey, how's this job doing? How's this job going? How's this job going? And once that response actually complete, the response will come back. Say, hey, that job is done. Okay, you can now do whatever you want to do. That's one way of solving the problem. RabbitMQ doesn't do it this way. RabbitMQ does it the push way, right? Where it's just like a stateful connection. I forgot what the protocol that RabbitMQ uses, but it's a very elegant way of using channels. It's awesome. I love it. And I'm going to make another video about this compared to HTTP2. The idea of RabbitMQ using channels, it's very similar to streams. And I don't know who came up with this idea. Regardless, back to the point. If I respond back, if that job is dequeued, right, or executed, that could push results back to the client immediately as they are received, right? So this way, you eliminated the latency of waiting. Client is still technically didn't receive the result, right? You don't receive the result, but I can unblock the user experience. I can show some sort of progress bar. I can give a better user experience. And I elevated the flood of requests on my server. Now I'm going to have a nice queue. Yes, it's a centralized system still, but it's a nice queue, and services can listen to this queue and start pulling jobs, pulling tasks, and execute and write it back to the queue, right? Very, very similar to a pub sub system, except the only difference between a queue and a pub sub, a queue is whenever you remove an item from the queue, is gone, right? That service owns it. It is dequeued. Versus the pub subsystem, you have a topic, very similarly, right? The brokers have these topics, and the service can as infinitely consume the same item. Many services can consume the same item, right? But now each service has some sort of a position that remembers, oh, I consumed this, yes, I consumed this, I consumed this, and the service optionally can have a way to go back and forth in the queue and the pub subsystem. So that's a very quick way of knowing how do you actually, when do you want to use a queue versus just a normal request process or system and load balancing and all that stuff, right? So very quick, if your request is indeterministic, you don't know how long it's gonna take, a queue is probably a good idea for you. If your process is by nature long running, a queue is good for you. Just queue it and let other process pick up the work and write it back to the queue. Or if it's resource hungry, if by default your process, backend processing is a resource hungry, it's a bad idea to have the web server itself do the work for you. The web server
Am I going in the wrong direction?
Shouldn't process your stinking request. It should just respond back to web traffic. It serves web. It is a web server. It serves web traffic, and that's it. Don't let it process your prime numbers or do a very complex operations in the web server's style. Try to separate concerns as much as possible. All right, guys, that's a quick video just to let you know the difference between when to use a queue, when to not use a queue.
Hope you enjoyed this video. Subscribe if you like this content. Like this video if you like it. We're gonna see you in the next one. You say, guys, stay awesome.
That blew up. Bad memories, man.
One of you guys asked me a question, which is better, REST or message queue? I struggled to answer for a while, but after thinking about it, I discovered that both REST and message queue does boil down to the basic elements, which are basically REST being HTTP, which is request response, and message queue being publish subscribe. In this video, I want to discuss both the request response and the publish subscribe architecture and talk about the pros and cons of each. So if you're interested, stay tuned. You're new here, welcome. My name is Hussein, and on this channel we discuss all sorts of software engineering by example. So if you want to become a better software engineer, consider subscribing, hit that bell icon so you get notified every time I upload a new video.
Oh my gosh, that guy said this intro way too many times already.
Let's do this. Alright, here's the
He sounds so bored.
What we're going to do is we're going to talk about request response a little bit, and then we're going to talk about where the request response actually breaks, right? Because nothing is perfect in life, apparently, right? And as I start talking about time code, where you can jump to the interesting part of the video, request response, pros and cons, that's another thing we're going to discuss. Right? What's the good, what's the bad about this technology? Publish, subscribe architecture. We're going to talk about that, how it actually works. What is it, right? With example. And then finally, we're going to talk about PEP/SIB, pros and cons. If you're interested, stay tuned. Let's start with request response model. It's a very elegant and simple design that had been designed in the 90s, and the whole internet is running on this thing. It's very, very simple design. That's why it's popular. So you're a client, you're a web server, and the client makes a request. Let's say this is a GET request over HTTP. The client waits. The client is blocked. Now you can argue with that whether it's blocked and cannot do anything else, right? Which is no longer true because we have asynchronous requests, right? You can make a request and you can do other stuff in the background. That's okay, right? Because it's just, you make a request, you wait, and you don't actively wait. You don't spend any processing power waiting, right? You just make a request and forget about it, right? And then once the request comes back, you get back the content, and then you do something with this content, right? So that's the request response model. It's always the client initiating the request. There is no other way coming from the web server. Okay, and I'm going to reference a video here for the synchronous versus asynchronous. There are a list of playlists that you can go and watch that if you're interested to know more. All right, and where does this break? Is this perfect? Obviously, nothing is perfect. Let's assume you have this system where you want to upload a video. Let's say this is YouTube. And obviously, when you upload a video to YouTube, you don't just upload a video. There are a lot of stuff happening in the background. So you want to upload the whole video. YouTube want to compress the video because usually it's that raw MP4 file is very huge, right? You want to compress it. Now after compress is done, you want to pick that up by the format service. You want to format it, and what does that mean? You want to produce different video types for the appropriate devices. So you want to provide a video for mobile phone, so that's maybe 480 or 720 or 1080 or 4K. You want to produce different kind of content, right? Based on the viewing platform and provide that. And you want to also, once this is done, you want to notify subscribers. So how do you do that with just request response? Well, it's still simple, but it really breaks down if you think about it. So client makes a request, uploads that beautiful raw MP4 video, right? And it waits, right? It can do other stuff in the background, but still waiting, right? And then upload service is processing that stuff. And then once it's done, now it is waiting, and it's making a request to the compress service to compress the uploaded video, right? Okay, that's making a request. Now the compressed video is processing, and when it is done, it is waiting and make a request to the format service and waits, right? So a lot of people are waiting. There's a chain of people waiting for this thing to get done. Format service is processing, producing all these 480, 720, and 1080, and 4K, and 8K. No, 8K, right? It's bad. I don't know if that's true. Okay.
Oh my
services
goodness.
is processing that stuff, and then once it's done, it will make a request to the notification service. Like, okay, I'm done. Let's make a request to the notification service, which
Oh my
notifies
God.
subscribers, obviously, that hey, we're done. This video is uploaded. Go and then the format service is waiting for the notification service. And you guys kind of argue with this, like, oh no, really, we can notify people once it's uploaded, right? No, really, we want to notify people when it's ready to be consumed. When it's here, it's not ready to be consumed, right? So and that even gets more complicated as we talk about it. All right, notification service said, okay, I'm done. The first response, format service said, I'm done. Compressor service, I'm done. So if people start unblocking, services start unblocking requests as they come in, and finally the client will say, ooh, done, uploaded. All right. Obviously, guys, put anything that breaks in the middle, the whole thing is broken. I'm sorry about that. Okay. So the whole thing is essentially broken, right? Once you put any obstacle, like network error, the whole chain is broken, and you don't know if this thing is finished or not. That's
What?
the problem we're facing with request response. If you're chaining multiple services, especially in
What?
microservices architecture, that breaks down. Let's say we want to add another copyrighted service, and we want this to the copyright service, like to check the content for content IDs and check if there's like a copyright infringement, right? So you want to consume, the compressed service need to send the compressed file to both format and copyrighted. Oh my God, right? This topology gets really complicated real quick, son, right? All right, what's good, what's bad about this? Pros. It's very elegant and simple, yes, if you have only two pieces of software talking to each other, that's beautiful, and I still love that. But once you get into complicated scenarios, not really, right? So elegant and simple, I love that. It's stateless, especially when you use HTTP. That's not really true for like request response like database. Like database, you make a SQL, that's still request response. You make a update table where blah equal blah, that's a request. And then when you get a better result, like hey, 17-year-old updated, that's a response, right? That's still a request response, but that's nowhere stateless. It's as stateless as it gets. Right? HTTP and other is stateless, but yes.
Oh
you can
my
argue with
gosh.
that, but it is, if it's stateless, it's good,
Just
it's
die.
scalable, right? You can scale it horizontally, and that's a very overloaded word. I hate putting it there, but I have to put something in the pros section. Scalable here means that it is scalable at the receiver end, where you can duplicate the receiver if it's the same content, right? If it's the same, has the same functionality, you can duplicate it easily, and you can scale it easily, right? Because it just makes the same request. Right? You can put it behind a load balancer, beautiful idea, right? Load balancer can just route requests to any service and just scales very nicely, right? But not really scalable in other terms, right? So scalable is a very overloaded word. And I'm really mean about horizontal scalability of the same duplicated service. Oh my God, that's getting complicated. Okay, what was that? Cons, what's bad about this? Obviously, as we said, it's very bad for multiple receivers. The moment you start seeing a lot of receivers, a lot of consumers, you start really wearing yourself down, and yeah, things can go really wrong with that. The moment you insert anything in the middle, right, your architecture falls apart. Okay, that's why you have to start hacking things around. How do you hack things around, right? You basically introduce high coupling, so a lot of services start talking to each other, which produces a lot of high coupled services. So services start knowing each other, and that's bad. We want software to have social anxiety. We do not want software to talk to each other. That's bad in software. High coupling is bad. We want software to be as oblivious as possible about the whole system. High coupling, yeah, we talked about that. Client and server have to be running. You won't say, Hussein, that's just weird. Of course, I'm gonna send a request. If the server is down, yeah, of course, the client and server have to be running to communicate. Are you telling me there's something better than that, where the client can go offline and the server can go offline and still they can communicate? Oh, we're gonna see about that. All right. Yeah, so that's kind of a disadvantage. PubSub has this advantage. Still have my concerns about that, but we're gonna talk about that. All right. So chaining, circuit breaking, retries, all that stuff that we introduce just to solve the problem of how can we guarantee that these topology of systems connect together, right? The highly coupled system can correctly talk to each other, right? We need to time out correctly, we need to retry if that didn't work, and that just put a lot of pressure on the service and complicate things even worse, right? And that is a problem by itself. It's not an easy problem to solve. Yes, service missions take care of that stuff. Like clients like Finagle on Twitter, that open source Finagle can take care of that stuff for you, right? If you make a request. But to me, still sounds like we have a very complex system. Right? Yeah. All right, PubSub to the rescue. It's the best thing ever. Not really. All right, so let's talk about PubSub. Publish, subscribe model. All right, we'll take the same example, the YouTube uploading service. And we're gonna upload the video, and we're gonna compress the video, we're gonna format the video, we're gonna notify people. How about that? So there is, as you can see here, you can see still the services here, the client here, the notification services, all that jazz. But there's some box here. This box is the middle layer that everybody's communicating. And this is called multiple names. People call it broker. People call it message queue. People call it streaming, processing, a lot of names, but it's a middleware layer where you can push and publish content to it, and it will take care of delivering that content to someone else, okay? Based on the subscription model. So these guys subscribe, these guys publish, everybody can publish and subscribe at the same time. And you publish and you subscribe and publish to what is called a queue, or sometimes called topic, like Kafka call it topic, RabbitMQ call it queue, channels is called, I think, Redis call it channels, right? So by the way, Redis and Kafka, RabbitMQ, ZeroMQ, all that stuff are just this message queue that supports PubSub, right? All right, let's go through an example, see if this thing is good or not, right? So here's what we're gonna do. I'm gonna make a client, I'm gonna upload the service. Still, this is, to an extent, this is still a request response, right? You can still mission mash. What does that mean, mission mash? I don't think it's a word. But yeah, you can do a hybrid between request response and PubSub, so that's okay, right? So you make a request, and upload service is still processing, waiting for all your stuff. So the client is blocked now, right? And again, guys, when I say
Yeah, I'm still alive.
They block doesn't mean he cannot do anything or she cannot do anything. Why am I referring to computers as gender? Okay, I don't know. Alright, so you make a request and it waits, right? It still can't do other stuff in the background, obviously, but it is asynchronous, nevertheless. So upload service, processing, once it's done, the upload service will say, you know what? Just give me a second. I'm gonna publish this really quick to this topic. And once I get the result, and which is usually this quick, because these guys are the same network interface, I'm assuming. This is another network interface. And this is another network interface, so they communicate with this. I'm hoping this is in the same, hopefully, LAN area. And they will communicate with like the 10 gigabit.
Yay, we have one user online.
That will
Ouch.
be fast, right? So we make a request, then
Yay.
really quick, upload that 5 gig video. Once it's done,
Ouch.
that's it. Your job is done as an upload service. So
What is going on here?
That it's done. Let's repeat that, right? So upload. Once it's done, publish it to a topic or a channel. Get back a result, and then shoot, upload it. Done. That's it. The client now does its job. You can disconnect the client. You can just move on with your life. The video is in the system, and leave. Right? Obviously, that means this guy has to be up all the time. But what we have here is essentially a topic, and that topic or the channel has the content. It's sometimes called a queue, a topic, a channel, and that has the raw MP4 videos. Now, how do people consume it? These guys would have been subscribed already to a topic that already exists. I just hide it, I didn't some animation. Compressed service in this case is subscribing to this topic. Now, we're gonna talk in details like how this is actually done. What does it mean to subscribe, right? It's very weird, abstract word, right? Are you pushing the result of the compressed service the moment you have a raw MP4 video? Or is the compressed service actually pulling information? Or is it like pinging? What's happening here, right? So you gotta tell me more, right? So the compressed service, there are multiple implementations. We're gonna talk about them, but push and long polling, polling, just polling is useless. I don't know why we would do that. It's just same as request response. But all right, so the compressed service will receive now the raw MP4 value. Imagine that it just got like immediately pushed to it, right? That has this limitation, obviously. We're going to talk about that. The compressed service will receive the raw MP4 video, start processing it, and guess what? It will publish its own compressed video to another topic that says, hey, compressed video, here is it. Right. It's a topic. So it doesn't really know who's going to consume it. The upload service didn't know that the compressed service is going to consume it. And that's the decoupling that we talked about. Just decouple that everybody from each other. The format service is now subscribed to the compressed video topic, and it will get it immediately. This is a little bit okay. Yeah, you get it, whether it's push or long polling, whatever. You get it. Format service, it's just like publishing content. Look at that. 480p, 1080p. This is Gary V, man. Format service is Gary V. Just producing content like there is no tomorrow. Format service publishes all that stuff so that it's done. Now, the notification service, let's say your notification, you want to notify people when the 4K video is ready. I know, this is a little bit harsh. You want to notify people the moment the 480p videos is ready. So it's up to you. You want, for example, to notify people when the highest quality video is available. That's gonna take a long time to notify people, obviously, but nevertheless, right, you got it. All right, and then you can easily fit the copyright service, right? We talked about it. Just slam it there and subscribe to the, I don't know, the compressed video, and that will just immediately find any content ID and then there, right? So it's a beautiful design. Is it perfect though? I don't know, let's find out. Pros, what's good about this? Let's find out. Obviously, it scales with multiple subscribers, right? Multiple receivers, multiple consumers is great for multiple receivers because you can add as many receivers and unique receivers here. We're talking about unique, different, distinct receivers, right?
They are different from each other. They have different needs. They have different wants, and they want to be scaled. You can scale them beautifully, right? Unlike the request response, where they have to be aware of each other, and that's bad. All right, so this thing is great for microservices. All right, it's amazing, right? Because the moment you have multiple services, in order to avoid the spaghetti mesh topology of everything is connected to everything, you can just have this one place and everything is connected to this place. Now you have almost like a single point of failure, but that can be dealt with differently, right? We're going to talk about the pros and cons. Loose coupling, you just decoupled things. Now the services are not aware of each other. That's good. We like that stuff, right? The moment that the less things are coupled to each other, the more they can essentially scale and be added, and the system can be modified easily, right? Because you can smartly change one thing without breaking the entire system, because coupling are bad. Because the moment you have a service that depends on 700 services, any small change can break any of these 700 clients, right? So if you're sure that your only client is the pub subsystem, you're golden, right? Works while client's not running. Well, yeah, but, right? So if we go back to the example there and we select the notification service, if any of these services are offline, we don't really care. The moment they come back online, they will subscribe and they will say, hey, we have a new message. We have a new topic. Let's consume it, right? So that's okay, because the message is already stored in the queue, in the topic, in the channel, right? So that's how, but that also means there's problems. Let's talk about the problem. Cons. All right, there are obviously message delivery issues. All right, so the message delivery issues about when we have a subscriber and we have a message queue, or we have a publisher and we have this message queue, and you're publishing something, how do you know that the queue, the message has been published? That's the first thing, okay? Well, you can say that, well, Hussein, message queue will send me a notification, acknowledgement, hey, you're done, good stuff, we're good, all right? And that, you don't care about anything else for the publisher, that's good, okay? If you don't receive the acknowledgement, you might try again, and that's a problem, okay? But how do you know that?
Oh, fuck.
If I publish again, how do I know I didn't publish the same content twice, right? We have ways of solving this with idempotency, but still, complication going on there, right? And who's taking care of this complication? Should it be me as a publisher? Or should it be the message queue? I don't know, right? The other problem is the subscriber. Now the subscriber, that's the challenging part. How do you know as a subscriber that this subscriber, this consumer, this compressed service actually got the content first? How do you know that it actually processed the content? Because it has to tell the service, hey, by the way, I read this message. Just the fact that this acknowledgement that, hey, I read the message, people are taking PhDs in this. Because it's so hard, right? It is so hard to know that a message has been consumed or not. How do you know? Right? You can send an acknowledgement, but what if the acknowledgement you didn't get it? All right, so we talked about the message delivery issues, obviously, and now let's talk about the complexity. It is a very complex system. Because of the message delivery issue, we try to find ways around it, okay? And to find ways around it, we add complexity. Okay, so this very simple part. Let's talk about the push and the pull and the long polling model. How do you deliver a message from the topic, right? How do the broker deliver a message from the topic to the subscriber or to the consumer, okay? How does that happen, right? You can imagine like RabbitMQ or Redis, and we made a RabbitMQ video here. I'm gonna reference it here so you guys check it out, but it's very interesting.
And what you want to do essentially is, first thing is you want to establish a two-way communication, like a TCP channel, right? And then RabbitMQ has its own protocol. I think it's not really its own, but it's a standard, it's an advanced message queue protocol. They're using that, and it's a two-way communication. It's a two-way binary protocol. And they talk about it. Redis have its own REST protocol. I don't know what REST stands for, but I forgot. So they, again, it's a two-way communication where it's like you communicate on both directions.
No.
And then now you can start sending push messages as a result because it's a two-way communication, right? And push messages, push notification, push models, very complicated. It might sound nice. Hey, the moment I get a topic, immediately push to the subscriber. That sounds beautiful because it's almost real time. But what happens if the client is offline? What happens if the consumer is offline? Okay, well, you can say, let's hold the message until they are online, and then when they are online, push it. Okay, that seems reasonable. All right, but how do you know that they are offline? Then that status, right? You're almost keeping track of the subscriber in your message queue. That might be okay if you think about it, but that adds additional complexity. Another complexity is the back pressure, where the publisher is so fast in producing content. Let's say a publisher is Gary Vee. It's just like grinding content daily, right? Not daily, every second, just publishing stuff all the time. And then the poor consumer can barely consume these messages. There's, right? There's just the flood of push messages. The little tiny device, for example, that consumes that stuff cannot handle that load. It just cannot. It cannot handle something that's shoved down their throat. Obviously, it's gonna wait, right? And what do you do with these awaited messages? Do you just put them back? And do you time out? Do you put them? And do you now keep track? Oh, this client is slow, so I'm gonna slow down. This client is fast, I'm gonna speed up. That's a very complex problem to solve by itself.
Oh my gosh.
Right? That's a problem, right? And then another problem is, okay, so you might say that's the RabbitMQ and Redis uses that. Okay, that has its own limitation. So the other approach is to do like the polling method, right? Where do I have a message? Do I have a message? Do I have a message? As a client, you say, do I have a message? 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 Well, if you don't, then you just kind of saturate the network with empty requests, with kind of busyness, right? Right, that's a problem. Okay, that's it. That's a lot of processing wasted cycles for requesting empty responses, right? There's nothing for you, so why you keep requesting? So the solution, the part solution is to use long polling method, which Kafka uses, right? Which is like, hey, you make a request and you block yourself, right? We're gonna block you, essentially, as if you made a request and we're taking a long time processing it, but there is really nothing to process. Nobody's busy. And because it's a beautiful of asynchronicity in this age, it's fine. You can wait, but you can do other stuff in the meantime. The only thing I spent is memory here. That's the only thing I spent. Maybe a little bit of an event main loop, just checking if there's something came back or not. But you're doing that anyway, right? So it's not much. So the long polling, that's what Kafka uses, right? And then that has its also limitation, obviously, because like you might not get best real time, but you solve the problem of essentially the back pressure of shoving a lot of messages for clients who cannot be ready to consume messages, right? Obviously, it's a very complex system. And network saturation, in case of push, you're pushing a lot of messages, you're shoving the network with a huge amount of notifications and content, right? That's a lot of content going to the network. Sometimes unnecessarily, because the client doesn't really necessarily can process these messages, which might lead to failure, which may lead to you retrying. The broker can have to retry these requests, which is also bad, right? And then network saturation, on the other hand, is like the other way, underutilization, which I didn't write here. It's just like, hey, I make a request, but I don't see anything. I make a request, I don't see anything. So, summary, what did we discuss in this video? We talked about where the request response model breaks, right? It's a beautiful design, but it has its limitation, right? We talked about the pros and cons of this request response. We talked about the publish subscribe pattern or architecture. I don't know what you call it, right? Publish subscribe architecture or pattern, whatever rocks your boat. And we talked about the pros and cons of that thing, okay? The example of this is Kafka.
Did he say
RabbitMQ,
walks your boat?
and Redis. We made a video about Redis. We made a video about RabbitMQ. I am making a video about Kafka. Still in the process. I'm gonna let you guys know. If you want to know, if you want to really see the video about the Kafka, write down in the comment section right now, write Kafka. So we can actually, I see there's a lot of interest in that. You guys give me a lot of great suggestions. I love those videos, suggestions. I'm making them, I'm enjoying making all this content. It's a long form content, I know it's a lecture. This is not a 3-minute video that you watch, right, and then you move on. This is videos that you watch if you're serious to learn, obviously. And no lecture, no 10-minute video can give you any value really, or 5 minutes video. You gotta watch and learn about a lot of stuff. Okay, that's the kind of content we make on this channel. So if you're interested, consider subscribing, like this video if you like it, share it with your friend. I'm gonna see you in the next one. You guys stay awesome. RabbitMQ is an open source distributed message queue written in Erlang and supports many communication protocols. It was trying to solve a problem with what we call the spaghetti mesh architecture. You know, guys, remember where every client is trying to talk to another client in the system? Remember, guys, the days of the enterprise message bus and all these god-awful days, you know? So RabbitMQ was introduced to solve this problem, right? By introducing this intermediate layer. In this video, we will explain the main basic components of RabbitMQ, right? And you're gonna start seeing jump codes or time codes here, guys, where you want to jump to the interesting topics, and you don't have to watch the whole videos, just whatever you're interested in, you can jump to that, right? So we're gonna talk about the RabbitMQ components such as the advanced message queue protocol, AMQP, what is a channel, what is a queue, what is a publisher, what is a consumer, what is an exchange, what is all that stuff, right? And then we're gonna talk about the meat and potatoes of the whole stuff, where we will actually spin up our own RabbitMQ server with Docker, okay? Then, obviously that's not enough, we're gonna write some code, we're gonna write our own publisher that uses NodeJS, okay? That publishes to the RabbitMQ server, okay? And then we're gonna write our own consumer piece with JavaScript, Node.js, that will consume that queue, that will consume these messages, okay? Finally, guys, I wanna talk about my thoughts, my personal thoughts about this technology. Finally, obviously, we're gonna summarize the whole thing. All right, guys, if you're new here, welcome. My name is Hussein, and in this channel, we discuss all sorts of software engineering by example. So if you want to become a better software engineer, consider subscribing and hit that bell icon so you get notified every time I upload a new video. With that said, let's just jump into this video, guys. All right, so RabbitMQ. So here's the architecture of RabbitMQ. RabbitMQ uses this middle layer and solves, as we talked about, solves a problem where clients want to talk to other clients in the same system or external systems. And instead of having each client having knowledge of other clients, we kind of grouped everything into this layer, okay? We call this RabbitMQ server. RabbitMQ server listens to 57672 port by default. Because it's a server, it has to listen, right? Because it's using TCP. Okay, so that's the first abstraction, the RabbitMQ server. There's a lot of pieces inside of that. I'm not gonna go through that yet, but I wanna explain that first piece, which is the server. This could be multiple servers, could be distributed, replicated, and all that jazz, right? But we have this first piece, RabbitMQ server. The second piece, or third piece, is versus the publisher, where, hey, I am a client and I want to publish a message for certain consumers that are interested in this message. And we're going to talk about an actual example, guys, where we write the code. But essentially what the publisher does is it establishes a stateful TCP connection between itself and the RabbitMQ server. And this is very critical to understand. It's a two-way communication. Okay? So the underlying transport protocol is TCP. Okay? It's not HTTP. Okay? It's using TCP, raw TCP. And there's a nice protocol on top of it. Okay? There are multiple protocols, but we're interested in is the advanced message queue protocol. There's like certain headers, certain messages, right? Think of it just like an application layer HTTP where it uses TCP, right? It has its own headers and body and get and methods and post, right? The advanced message queue protocol has its own format as well. It has its own protocol. Okay, so it uses that. Okay, and then it uses that, and publisher can send messages to the server. The server can send messages to the publisher. So it's a two-way communication. Very critical to understand. Okay, so there is a connection. So that's the second abstraction. A connection. Third abstraction. So a publisher, a connection to the server. There's a consumer who want to consume messages, so they will connect again using a stateful two-way bidirectional TCP connection to the server using the advanced message protocol. There are other protocols, but I'm not going to talk about this in this video, right? So let's focus on just one protocol here. So the AMQP protocols. Man, that's hard to pronounce. All right.
Oh shit,
so
there's a wither.
the consumer establishes a two-way communication with the server and says, hey, what's up, server? Sup, give me some messages, right? So, and the server will start pushing messages. Emphasis on the pushing, guys. Very strong word here, the pushing. The server pushes messages to the consumer, okay? Very interesting, okay? So the server pushes messages to the consumer when they are ready, okay, when they have messages. And there is the publisher send messages to the server. Another abstraction for RabbitMQ is what they call the channel, okay? And the channel is a logical connection in your connection. It's just like a mini connection, think of it, right? And the reason they did that, they want to separate the consumer connection from multiple consumers inside that consumer. An example would be you would create this consumer have 3 channels using the same TCP connection. And the reason they're using that is just instead of, if you're trying to, like, instead of having 3 consumers having 3 TCP connections, let's have 1 consumer with 3 channels with 1 TCP connection. This is called multiplexing, where you bring a lot of stuff into one pipe. And that's a good thing. I like this about it. I like it a lot, right? You can use the same TCP connection, but you can send certain bits with the channel ID. Say, hey, this is, by the way, this belongs to this channel, this belongs to this channel, this belongs to this channel. So they can segregate and do certain things based on that. So that's a nice abstraction, right? A channel, okay? Same thing with the publisher. So you can send through a certain channel, okay? If you don't have channels, then the publisher, let's say you write a publisher that does more than one thing.
Oh
okay?
my gosh, you shot at me.
You will be forced to use multiple publishers instead of kind of putting all your code into one publisher or one consumer, right? Another abstraction is what the Q stands for, is the queue, right? All of this stuff goes into the queues, okay? So the queue is that you send an information, it goes to the queue, and then the consumer will basically pull information from the queue, right? And that's where the queue is, right? But however, that's very important. The publisher and consumer are not aware of queues, okay? Technically, they are aware of what they call exchanges, and that's the 7th abstraction of this RabbitMQ, okay? There's an exchange where the whole thing is an exchange. There's a default exchange, and you send all this stuff to an exchange, and that will take care of propagating into a queue, right? You don't have to know about this. We're not going to talk about exchanges. Well, we're going to use the default exchange, which takes care about a lot of stuff, right? An exchange can be used to use different algorithms to kind of fan out and do a round robin into different queues, but that's out of the scope of the video as well. have exchanges, we have queues. But let's just think about the concept of a queue where you put a messages, publisher publishes a message, goes to the queue, consumer consumes a message from the queue, and the exchange is that default exchange then, right? You can have multiple exchanges as well. All right, guys, how about we spin up our own RabbitMQ and we play with this thing, okay? All right, guys, so to spin up our own RabbitMQ server, I'm not gonna tell you to download and install that thing, right? You don't have to pollute your machine with these installers. So what you have to do is just install Docker, make sure you can say Docker, and you get some sort of a feedback here, and you make sure you can do Docker run hello -word. If this gives you back hello Docker, that means you have Docker installed. Once you have Docker installed, we're gonna spin up our own RabbitMQ message container, if you will, and that message container, message server, that container will have a RabbitMQ server from which we will start writing code, okay? We're gonna talk about what we're gonna write, but let's first spin up that thing. How do we do it? Very simple. Okay, so first thing we wanna do is write Docker run, okay? And by always, make it a habit to give your container a name. Let's give it a name, RabbitMQ, okay? And then once we give it a name, we will expose the port of that container to my machine so I can communicate with it, right? So that's essentially what's the default port of RabbitMQ. You have to memorize that, 5672, right? And that's what I want to expose to my machine. This could be anything, right? The second part, 5672, is what is inside your container, right? That has to stay. 5672. This could be anything you want, okay? And then also let's just use this default thing, okay? And then finally we do RabbitMQ, and that's the image from which we're gonna pull the RabbitMQ Docker image, from which we're gonna spin a container. Let's go ahead and spin that, and just like that, we're gonna start downloading all that stuff, right? And then, yeah, just like that, this terminal is now occupied, right? So you can start seeing the messages that goes into this Docker container, which is the RabbitMQ, okay? Now, we have a container that is running and have RabbitMQ. What we're gonna build with this technology? Here's what we're gonna build. We will build an asynchronous job execution, okay, engine. And how this works is essentially, we'll have a publisher that will publish jobs and say, hey, consumers, I want you to execute this job, and I want you to execute this job. And then there will be a consumer, which is essentially a process that will take that job and start executing it, right? This could be like, think of it like you're publishing tasks, and these tasks are executed by actual processes, right? And this could be heavy process, like, I don't know, calculating a prime number of certain number, or finding, or going to the database and doing a bash job, or doing a Hadoop job, right? A map reduce, right? So all kind of jobs. We're gonna publish it to the queue. We're gonna publish it to the RabbitMQ message, and then the consumers will start polling they will get that message, get that job and start executing it, all right? So now that we know what we're gonna build, let's go ahead and build it. All right, guys, so what you're gonna need here is you're gonna install Visual Studio Code or any favorite editor you have. I'm gonna use NodeJS as my execution engine here to build my publisher and consumer. And here's what we're gonna build, right? So let's go ahead and build a publisher, okay? My publisher and consumer will live in the same project. That's okay, because we're gonna have a different kind of input to things, right? So let's go ahead and build the project. So you go ahead and go File, Open, and then we'll go to JavaScript here, Playground. Let's create a project called RabbitMQ. It's a blank folder. We're gonna go ahead and create a publisher.js file. And here's the thing, guys. Let's go ahead and initialize npm. So we create a project. npm init-y. That means shut up, I know what I'm doing. just give me a package of JSON. We're going to use that later. And now, here's what I want to do. I'm going to create a const. And then what we want to do is, we talked about this a little bit when we explained that, right? And we talked about RabbitMQ uses the advanced message queue protocol, the AMQP. And this protocol has a lot of clients, and Node.js has that client. So I'm going to create an advanced message queue protocol instance, and then we're going to acquire that library, which is called a advanced message queue protocol library. Okay, that's what it's called. And that's a promise-based library, which is amazing because we allow promise-SSI and stuff. It's using a thing, Bluebird to promisify. Promise, oh God, I can't promisify those things, okay? So I have that. So what is the first abstraction we do, right? I'm gonna create a connection to my server. Do you remember where my server is running? Do you remember the port, guys? I hope you do. Yeah, because now we're gonna use that. But first of all, since we're gonna use a promise-based thing,
No.
function. Obviously, it's gonna be an
Oh my gosh, I almost failed to load it, right?
Connect, right? Can't call publish anything. And we're gonna do a try catch, just to catch any bad things, right? And then console the log, the error, ex. So just build a skeleton. And here's the first thing we're gonna do. We're gonna do a connection. Create a
grab
connection.
it,
How
that's
do we do
nice.
that? AMQP dot connect. That's not hard. What do you expect? You want a string from me. What's the URL? Here's the URL, guys. Since we're using the advanced message queue protocol, that's the protocol we're using. And since my RabbitMQ is running on my Mac, it's going to be localhost or the machine.
Oh my gosh,
So what is the
the
port,
whole
guys?
sponges.
5672. I can't memorize that thing, okay? And here's the thing, guys. Since this is returns a promise, right? Bluebird, that means it's a promise. You gotta await that thing. Await that thing. And here's my TCP connection. Remember, there's another abstraction with RabbitMQ, which is called a channel, which is just one channel that goes in your connection. So you can create, I don't know what's the maximum number of channels per connection, but you have to create a channel because that's the channel of communication. So that's not enough. So let's create a channel. How do you create a channel? Again, you await the connection dot create channel. That sounds not hard at all. Okay, that creates also, that's a promise base, so that means it will be awaited. If there's a rejected promise, we're gonna go here. You can use then dot then, up to you guys. But here's the thing, now we have a channel, what do we do, right? The idea here is we're gonna publish to a queue, okay? RabbitMQ documentation says the client doesn't know of a queue. I kind of disagree because I write a queue job. I literally specify the queue name in my publisher. That means, so don't tell me that the client is not aware of that queue. It just doesn't make any sense to me, right? So the client is aware of a queue, right? But internally, you kind of publish to an exchange. But I don't know. It's just whole just mumbo jumbo abstraction to me, right? I don't believe in any of that. So a channel can do something called assert queue, and that assert queue will make sure that your queue exists on the server, and if it doesn't, it's gonna create it for you. So what do? We're gonna create a queue that's called jobs. Right? And let's just use the default. There's like whether you want it durable, that means persistent disk or not. Let's just use the default here. Okay, and then const result equal await. Since this is also going through the TCP, you gotta await because it's gonna take some time. Await everything. And to know, basically, if you see Bluebird as a result, that means it's a promise based. Okay, we got a result. Now we got a queue. What do? We asserted that we have a queue. Right? If you don't do this, you might get an error of the second statement. So here's the thing. What do? Now I want to send something. Send to a queue. What do we send? Which queue? Which queue are we sending in? I'm going to send to the jobs queue. What do you want to send, son? I'm going to send an array of buffer, essentially, which is just like a buffer. And the buffer is you have to send a buffer, and to send a buffer, you can do buffer from and then pass a string. So let's just send a JSON object here, and then let's just do a message. What's our message here? What's the message? What are we gonna do? Const message equal. Let's say I'm gonna send a number here. Okay. And this is the JSON object with the number 2, right? Or 19. And then I'm gonna send that JSON object. So you cannot send just the JSON object as it is. You have to stringify it. So you're gonna do string JSON to stringify message, and that string will become a buffer. So you obviously need to send a buffer. You can also, if you want just to send text, say hi, you can do that, right? But we want to be fancier, guys. We want to be fancy. Okay, we send the job. What else, guys? Is that it? Is that all? I think that's it. So we can, if you want to, you can close the connection here, okay? And just be happy. But let's just say console.log, let's say job sent successfully. Right. And what's the job? That's the job. What's the job? The job is the number. I don't know, you're sending a number, and that the process will take that number and process that input, right? Think of it as an input. You're sending a message to the queue. And then one of your processes will pick that and start processing that. Okay? Whether it's going to do whatever, right? Okay, how about we run this thing, guys? Before we run, we have to call this function. We never called it. So let's go ahead and run it. And hopefully that works. Let's do it. It might fail because I didn't install. Yep. Cannot find module AMQP-lib. Well, how do we install a module? Very simple, sir. We do npm install AMQP-lib. Just for you to see it, guys. We have to install the library that we use. It doesn't come default by now with NodeJS. Okay. Now we have it. Let's run. I'm gonna, by the way, guys, give you the code so you don't have to worry about pausing the video and doing all that stuff, right? So get a channel. After we get the channel, we got the channel successfully. What is the result? What is that? So it gives you back the queue, essentially. So we can print that queue if we want. Okay. And then that sends to the job. And then we say job send successfully. And then obviously my debugger is still running because we didn't kill the connection, right? So it might be a good idea just to kill the connection afterwards. Okay, so we submitted something to the queue. How about we consume it, guys? So let's create another one. Right. Another one, consumer.js. Who is the consumer? It's the same code, almost the same code. So here's what we do. Same AMQ. So it's just steal code, guys, because it's almost the same, but I don't want to do all this mumbo jumbo, right? I don't want to send anything to the queue. I want to do something else. So let's delete that. Okay, so that's, I don't think I need a message because I'm consuming messages here. So we connect to the server. We did the channel because you have to do a channel. By the way, this channel is different than the channel of the publisher. They are completely different channel, right? They are completely different TCP connections to begin with, right? So what I want to do here is we have to keep the consumer alive, unlike the publisher. Publisher, you can actually kill the connection if you want after you're done. But you might want to keep the client, the consumer, happy and dandy. So what you want to do is a console.log listen, waiting for messages, something like that, right? We're just waiting for messages. But how? How do I get messages? Well, you do this. Channel.consume. And guess what? What do you consume, guys? You consume a queue. And what's the queue name? It's called jobs. And what do you want to do when you consume a job? I want you, sir, to call this function when a message comes in. Okay? And here's what I want to do. I just want to do console.log, all right? And then just print the message, okay? And then I'll go, pay attention to what will happen here. I'm gonna run this thing now. I'm gonna run the consumer. And let's see what will happen. This is a debug. I put a debug here. So after the connection, if the server, which is RabbitMQ, sent me as a consumer a message, I am going to get triggered here. And here's what we're gonna do. What we're gonna do? I just want to print what we got. Oh, we went to the publish option. All right, so let's run my consumer. Ooh, nice, look at that. So we got a message. What does this message have? It has a content. That's the buffer we got, you guys, remember? We sent a buffer, we get a buffer back. How do we get from the buffer? We get a string back, which is what we're interested in. We're gonna talk about that. So it's unreadable. So let's make it into, oh, we didn't get the message. It is pretty coolish, guys. All right, so here's what I'm gonna do. If I restart it again, what? I thought a queue, when you just read the message is dequeued, right? But every time I restart the consumer, I always get the same message again. Let's print it so we can see. Content.toString. Just print it. Let's see what we get as a consumer. And look at that. We got the number 19. Okay? It's a little bit boring, so let's make it into actual JSON, right? Input equal JSON dot parse, right? This is how you convert a string back to JSON, right? We get the JSON, and then we do console.log received job with input.number, right? That's the function. And then let's do the fancy text here. Literals. All right, guys. Let's do that. Consume again. We got it. Then we get receive job with input 19. Now you can take that number, query the database, do your thing. And here's the interesting part. The reason we keep receiving the same message over and over and over and over and over again, right, is because we did not tell the server that we have received it as a consumer. That's what's called acknowledgement. I didn't talk about that, but we're gonna talk about it a little bit now. Okay. So what do we do? All right. So let me first clean up some stuff, guys. Right? I want to do there's two certain things. I want to create a script here in npm so that if I do npm run publish, right, I will run node publisher.js. Okay, that's what I want to do. And if someone says consume, I'm gonna go to node consumer, is that what we call it? JS. Okay. This way, if I go to a terminal, okay, if I do a terminal and do npm run publish, I'm going to publish the message. Okay, and let's kill it. If I do npm run consume, I'm going to consume that message. And you can see I received 2 jobs with the same ID because I just published another one. Another thing I want to fix here, let's kill this job. In the publish, I want to publish a number that the user sends me. How do I do that? Right? I want to do npm run publish, and then I put a number, and that number will be published. This way, we are always hard coding the number 19. We don't like that, right? So here's what I want to do. To do that, kind of hacky, but why not? So do process.argv, and I believe it's the third element of the input will be the input, right? Because I think 0 is the NodeJS.exe or whatever in your Mac, what's it called? I forgot. The second thing is the path to the JavaScript. The third thing is the input, right? So if I do that, that will be the input. So let's try that. So now if I do npm run npm run publish 8, job sent successfully 8, right? It's pretty cool. If I do npm run consume, yay, we got 19, 19 and 8, okay? So we keep getting these jobs. Here's the thing now, okay? So we now have that. Let's get out of this and show you that we can actually run it out of the terminal, right? This doesn't have to be in the Visual Studio Code. So let's go ahead and do something fancier here. I'm gonna create a new terminal, right? Let's go ahead and create another terminal here. All right, so I have two terminals here. What we're gonna do is go to the same folder, which is I think called JavaScript Playground, and then it's called RabbitMQ, right? And then what I'm gonna do is npm run publish 7, and just publish 7 successfully. And I'm gonna do here is go to the same folder, JavaScript Playground, RabbitMQ, and then npm run consume, and then we can see that we got all of them now. Okay? So that's just another way of consuming stuff. Here's the thing, guys. The last thing before we end this video with the exercises, I want to tell the server, please dequeue this job because I have processed it. How do we do that? Here's what we do. Go back to the code.
Oh my god.
The consumer job is to dequeue or to acknowledge that they received that job in order for the server to pull it from the queue, okay? There's a lot of stuff here. This is a complicated topic. Kafkas have their own implementation of how, like, guarantees of delivery, like at least once, or at most once, or exactly one, right? So there's like a lot of guarantees, but which I'm not gonna go through this because it's just gonna get longer and longer, or that would be another topic to discuss. But the RabbitMQ guarantees, I think, at least once delivery or at most once. It cannot guarantee that exactly you received it once, right? It's just a little bit tricky stuff that people take PhD in, right? This is really complicated. It's even above my head, really. It's just really complicated stuff. All right, so here's what I think. If I received a message, I want to acknowledge the message. Certain thing. Let's say if the input.number is equal to 7. Just type it. I just want to process number 7 for some reason. I don't want to process all the keys. Go ahead and do channel.ack. And you can acknowledge everything. You can acknowledge just a certain message. So I'm going to acknowledge this particular message, which is called message. Right? When a message is received, if that message is satisfied certain criteria, let's say you went to the database and you processed it and you got a successful message, you processed it, you run your Hadoop job, you got all of that stuff, you run your everything, and you got back the results you want, the way you want it, then you can tell the server it's safe to remove it from your queue. And that's what acknowledging means. Okay, let's go ahead and acknowledge this thing only. Okay, so if I go back here and I say npm run consume, you can see that I received job with all of them again, but this one was acknowledged, but it doesn't show here. So now if I kill that consumer and I run another consumer, you can see that it's still there. This is a problem with, it's my problem now. I'm gonna tell you exactly why. It's just a JavaScript, it's something with JavaScript, right? All right. The reason it was not acknowledged is because I think this is a very JavaScript thing, right? Where I told it, hey, if the number is exactly equal 7 and the type is also matching, right? But I bet that this number is actually a string. It's not actually 7. So if I do just double equal, this will work. So let's go ahead and
or you pass it as an integer, that might be cleaner.
What happens here is equal, the reference quickly, really quick. Triple equal, that means the numbers, the values do match without implicit conversion, right? That means if this is a number, the second side has to be a number. If you say just equal, that means this is true, right? if you do...
That's so messed up. The string 7 is not the integer
This is
7.
true. But if you do this is actually false. Right? That's the difference. Okay? So now that we actually coursed it, let's go ahead back to the terminal. And clear. VM run consume. You can see that we have acknowledged it, hopefully this time. Run it again, and then it's no longer there. Alright guys, long video, but hope you got some benefit from it. So let's jump back to the slides, continue this, give you my take into this technology, then we can summarize the video. Let's go back. Alright guys, so we finished the consumer, we built the consumer, we built an asynchronous job system with RabbitMQ. We have a publisher, we have a consumer, we send a job and we execute it. We'll have all this fancy stuff. And we talk about all the beautiful stuff in RabbitMQ. And here's my thoughts about this technology. It has too many abstractions. And here's the thing my old boss told me. It says, if you building a system with a lot of abstractions and you want to introduce a new abstraction, you gotta remove an abstraction. You have to remove something. You cannot have this many abstractions. What do I mean by abstractions? Well, let me explain to you. Right? When I started researching this technology seriously last week, I was so confused because there are so many terms for this technology. It's a message queue. What the heck are you guys doing? What the heck is a publisher, consumer, channel, exchange? What else? There was like so many things. A channel, and then connection, and then two duplets, and then push and pull. So many stuff. And then they are supporting 3 or 4 protocols. So there's the advanced message queue protocol, and there's the Storm protocol, and there's the HTTP protocol. Too many abstractions. You know what you get when you have too many abstractions? You get a complex system. And complex systems do not scale with a human. We are not designed to work with complex systems. We are not designed. And this is my opinion. Take it with a grain of salt, guys. You might be smarter than I am. But if you're introducing this much complexity, right? I don't know all the abstractions. This is just a few of the abstractions. I'm pretty sure there are more. And if you're introducing all these abstractions, your system is going to get complex. And if it's get complex, adoptions will slow down. Okay? And that's why I believe RabbitMQ is getting less and less popular over these years. And that's one of the reasons, in my opinion. It's just too complex. Does it do the job? Of course it does. But if you figure it out, right? There's like, and I didn't even go deep into this technology. I was just like, you know what? I'm just gonna scratch the surface. I'm not gonna go deep because it's so confusing, right? So to me, it's a very complex system, right? Another thing I want to talk about here is the push model. The decision that RabbitMQ team did. It says, as a consumer, if you connect to a RabbitMQ server, which is called an exchange, which is ultimately goes to a queue, through a channel, my God, look at all this stuff, right? That's what I'm talking about. Look at how complex to talk about things is so much. Look at HTTP, how simple it is. Request response system over TCP. That's it, right? That's a whole internet is running on this thing, guys. Difference between this. See how complex this thing is. And I think the RabbitMQ community made the same problem with the Enterprise Server Plus. It's a little bit better. Enterprise Server Plus, ASP was even worse. It was so complex. And it's just an equalizer between whether you want to have a completely open system, extensible, versus a simple system that is kind of closed. And I don't mean closed source here, closed in limited functionality that it gives. Right? Redis did this very well, I think. Redis is it's an in-memory database. Yeah, we can give it durability, but we can give it functionality. Very simple, publish, subscribe, and that's it. Right? It's a very limited set of functionality. And Memcached, I didn't research Memcached, but it has the same concept, which is a very simple model. Simplicity rules, guys. So let's talk about push model. So when a consumer consumes a certain queue, RabbitMQ pushes messages, as you saw, guys. I didn't ask for it. I didn't actually say, hey, do I have a message? Do I have a message? Do I have a message? I didn't do that. I just said, hey, by the way, if you got a message, push it to this function, and the function got called and triggered, and then we got the result. Right? The problem with this is it does not scale. How do you guarantee that the consumer will receive that message, right? And how do you not overwhelm the consumer? Because, guys, remember, I am just a consumer. If you have like 1,000 messages and you're pushing this down my throat, there's this what is called a backfill problem, I think, where as you start pushing more messages, I cannot process them fast enough for you. So now you're kind of putting more work on the server, right, to start pushing, start slowing down the pushing process, because now you think the server says, hey, server, please slow down. That's the option that RabbitMQ have. I think it's called the maximum something, right? So it's like, hey, by the way, I can only process 5 messages in a second, right? So don't send me more than 5 messages. Now you're pushing this complexity to the server. That's why your server became more complicated, and that's an unneeded complexity on the server side. The server now will start pushing more and more messages to you, and they start, this consumer is slow, this consumer is fast, so I'm gonna pushing more messages to this consumer versus this one. It's very complicated. Kafka, I think I agree with what Kafka did with this, and they said, you know what, we're not gonna do a push model, we're gonna do a long polling model. Pull it back, push this complexity on the consumer, and let the consumer consume whenever they want, right? Whenever they're ready to consume. They run into another problem, which is the acknowledgement problem, which they solved in a very smart way. I didn't research Kafka in detail, but when I do, and leave a comment in the comment section below if you want to see the Kafka message, right? A Kafka video. And I'm really interested to make that video. But I think Kafka did a better job at this by shoving that responsibility to the consumer, to the client, instead of having the server push messages, right? So that's what we're doing with the notification system as well. Like, why YouTube have problem with notification? Because of the push system, right? There's always pros and cons with this. Redis picked the push model, but I would understand with Redis. It has limited clients, consumers, because it's all back-end technology. Unlike this is very front-endy, the message queue, because consumers will immediately consume the RabbitMQ message queue. Versus Redis, it's always a caching technology, so it is always going to be in the back end, deep back end. So the number of clients will be limited compared to the number of clients to RabbitMQ. I might be wrong, I might be mistaken, but that's my take on it. Hopefully you guys give me your take on what you think, right? All right, guys. Summary, what did we discuss in this video? We discussed the components.
It's empty, isn't it? Oh, fuck.
Right?
But they have sponges.
I don't even remember them ones. There are a lot of components about exchange and queues and publisher and consumer and channel, connection. There's other stuff that I didn't discuss. We discussed RabbitMQ. We discussed how to spin RabbitMQ server with Docker. I think this, if you want to try anything, use Docker all the time. Don't install garbage on your machine, guys. Don't install things that just take memory. Whenever you install something, a piece of technology, do Docker start RabbitMQ. When you're done, Docker stop RabbitMQ. So you just, even if you restart your machine, the containers will not start by default. So you try and save memory, right? And if you're done with it, Docker rm RabbitMQ. Okay. We wrote the publisher, right? We also wrote the consumer, and what we did is actually we built an asynchronous job system where a publisher publishes a job, and the consumer just starts and pick a job and start working on it, and then do his thing, and then produces the output. Okay. And I finally gave you my thoughts about this technology, guys. Hope you enjoyed this video. I'm gonna see you in the next one. You guys stay awesome.
Oh no. A wither.
What is going on, guys? My name is Hussein, and in
Oh, no,
today's
that's
video,
bad.
I'm gonna spin up a cloud version of RabbitMQ using the Cloud Advanced Message Queue protocol. So the Advanced Message Queue protocol applies for many messaging queues, right? And one software that uses this protocol, at least one protocol, is RabbitMQ. So in this video, I'm going to spin up one RabbitMQ instance on this service, and it's very simple. And I'm going to create a publisher and create a new queue on this instance, and then start consuming the same instance from a consumer that I'm going to build. I'm going to use NodeJS to build these applications, and this is just to tell you that you don't have to basically spin up these RabbitMQ instances on local on your machine, so you can just use one of these services, and it's really nice and easy. And how about we jump into it, guys? All right, so I'm gonna go ahead and go to cloudamqb.com and hit enter, log in. This is my email. Feel free to email me anything, any questions. I really appreciate all your stuff, guys. And we go ahead and create a new instance. And what we're gonna do is gonna call it, I don't know, test, and you can choose any plan you want. Free is more than enough, right? I'm just gonna go ahead and select region, east, really whatever you want this instance to be. The closest thing is the west, and I'm gonna pick it like, I don't know, North California. Sure, this is the closest to me because I'm in California. Go ahead and review, and just like that, $0 a month. By the way, this is not a sponsor or anything like that. It's just I just enjoy their services, and I thought I would just give it some love and try their service. So go ahead and create instance, and just like that, we have a new server, RabbitMQ Manager. You can go to the RabbitMQ Manager, take a look at that. Obviously, I don't have any queues, I don't have any exchanges, I don't have any channels, nothing, right? So all I'm gonna do is go to edit, and let's take a look at the services. That's the host. That's the host, Baba. And this is the AMQP URL. So I'm gonna go ahead and copy this puppy, and let's go to the code, guys. How about that? Go to the code. This is the code, guys, I'm gonna share with you. I have done a RabbitMQ crash course. Go check that video if you want details about what RabbitMQ is, what is all that stuff, what is a channel, what is a connection, talking about all that stuff, where we actually built this application from scratch. But in this video, I'm not going to show you how I'm not going to build it from scratch. I'm going to consume this stuff. All right, so publisher. The publisher will connect to the RabbitMQ server, which is currently set to my local host. I'm going to change that, and I'm literally going to put this huge URL that we got from the server. Right? And going to connect to the server, going to create a channel, because this is like the stream level. Just like HTTP2, create a channel, and then we can do stuff in this channel. We can have many channels. By default, I think the servers give you like around 200 channels by default. That's pretty much for free versions enough, right? We're gonna create a new queue called jobs, and we're gonna send content to the queue based on whatever the parameter that we send to this application, right? This I'm gonna send a number, and then once this number, we're gonna make it into a JSON, and then send it back to the server. And then the moment we send it, we close the connection, close the channel, and close the connection. At the other end, I'm going to consume that new content, right, on the consumer side. Right? How about we connect and test this thing? Node publisher.js, and I'm going to send the number 107. Boom. Just like that, we have connected. We have sent the job, we have created a job queue, because it didn't exist, right? This is what a search does. And then we send the queue, and then we close.
Where's my pickaxe?
And then we close the channel and we close the connection. Let's look at the...
That creeper made me nervous. I think I dropped my pickaxe.
How do I go to the dashboard?
What the fuck?
RabbitMQ Manager. Right? Look at that. We got a brand new queue. It's called jobs. How about channels? There's no channels. Weird, because we just closed the channel, right? And yeah, that's the jobs. There's some content in it. probably. This is the queue message. There's one ready, hasn't been. There's no connections, and yeah, there's all this stuff. There's one queue, 7 exchanges. I don't really have any exchanges. These are the default exchanges, I guess, right? I never used these exchanges in RabbitMQ, so I'm not really familiar with it. But yeah, let's go ahead and play with the consumer side of this. Start consuming this. We'll take this thing, consumer, and yeah, and just do the same thing here, huh? Let's connect. And
Oh fuck, I failed to load one machine.
Same exact thing, right? I'm gonna connect, create a channel, assert that the queue exists, right? We don't really need results. We're not gonna do anything with the results. And then we start consuming. And the moment we consume anything, we receive the job with the number and we print that number. And that's this is just was like some example with the axe and stuff. I want to acknowledge that stuff. But I'm not gonna acknowledge anything. I'm just gonna consume and print. Let's go ahead and do that. Node consumer.js. I'm not gonna pass anything else. When I do that, so look at that. Receive job with input 107, and the connection is still there. I did not close the consumer for some reason, right? I want to show you that if I go back to the dashboard and go to channels, look at that. We have a channel that is open. It tells you this is my public IP address. It's dynamic, so don't worry about it. The moment I restart, my router is going to give you another stuff.
Yeah, but it probably leaks your location, doesn't it?
That's my local port apparently. Queues, that's the queues, the high availability queue, and all that stuff. So yeah, and if I kill my queue, my consumer, and I did this, I'm going to receive the same thing. You know why, guys, right? Because we have not told RabbitMQ to actually dequeue that job. However, while I'm working on 107, that job 107, if someone else connected to the queue at the same time, what they will do, let's do it. How about that, actually? Just node consumer.js. It's create 2 connections. Look at that. This puppy did not get the queue. Did not get 107 because to RabbitMQ, right, the other puppy is using the 107, right? But the consumer did not acknowledge it, right? So for all we know, if I kill this connection, I go back, let's see what will happen, right? Look at that. Because the first consumer died, I go to the second consumer, immediately got the job because they say, hey, looks like this consumer didn't acknowledge me, right? That's why acknowledgement are very, very tricky to get right, right? So that's why get that thing right, guys. And I talked about this stuff in RabbitMQ. All right, guys. So very short video to talk about RabbitMQ and how to spin up a RabbitMQ in a cloud version. I think that's what the first video I make on a cloud. I started using the cloud more because it's just very convenient. Alright guys, that's it for me today. Hope you enjoyed this video. Give it a like if you like it. Share it with your friends. I'm going to see you on the next one. You guys stay awesome.
What is going on, guys? My name is Hussein. In this video I want to discuss RabbitMQ and HTTP2. RabbitMQ, I made a video about RabbitMQ. Check it out, guys, here. It's a very interesting message queue that I have my doubts about, but I'm a little bit changing my mind about it because it's a really, really great tech. And it had a feature that I fall in love the moment I heard about it, and it's called channels. And let's talk about that a little bit, and then compare it to HTTP2 streams that also we're going to talk about it. Right? So when you have a RabbitMQ server or a broker right here, right, and you have a client, which is usually called a consumer, the client establishes a TCP connection between itself and the server. And we know how TCP works. Guys, check it out. There is in the client library for RabbitMQ, they add some abstraction called a channel. And the reason they did that is like every request you want to send to the server, you have to specify the channel ID. They have headers for every request they send, tagged in the channel ID. You might say, why do you want to do this? This is so awesome technology. The reason is, instead of having multiple clients to establish multiple TCP connections to the server, you now have one TCP connection, and all of these requests are funneled in the same TCP connection. And now you can send a request and expect a response back, even if that request is already, you're sending another request in the same TCP channel, because they are very uniquely tagged with the channel ID. So now we can simultaneously send requests on the same TCP connection. And that's exactly how HTTP2 works, guys. The idea of streams. Browsers before HTTP2, what did they do? Remember, every request you send, you can only send one request at a time. And you better send one request at a time, because you cannot, we don't know that response that comes back, which request was it for? Because it's just garbage data coming out and in, right? So they made their decision way back, so always send one request and wait for the response to come back, and that request must be for that response must be for that request, and so on. That's called essentially head of line blocking. So it's like, so that the rest of the requests are blocked until that response is actually the first response received. And that's a problem, right? That same problem exists with TCP and any request response system. So what RabbitMQ did is they added this abstraction of the idea of channels in the TCP connection. So every request is almost uniquely identified in the channel itself. That is very similar to the idea of HTTP2 streams, which we talked about right here. Go check it out. So HTTP2 streams serves a very similar idea. You have one TCP connection instead of 6, like what the browsers used to do in HTTP1. And then if you make a GET request, they are tagged with the stream ID. If you make a POST request, simultaneously they are tagged with the stream ID. If you make another GET request to fetch an image, if you make another request to fetch an CSS or an HTML file or a JavaScript file, they are tagged uniquely with a stream ID, very similar to the channel ID, and they are shoved into the TCP connection, right? And now, when you come back, the response that comes back is tagged with a stream ID, so you know, this response is actually for this stream. All right, so you actually can assemble things in the client. So it doesn't matter what the order comes back. If this comes back or this comes back first, it doesn't really matter. So even if there are some delays, right? So why I made this video is like, I'm not sure who actually invented this idea of multi-concurrent tagging of requests. So RabbitMQ or HTTP2 or Speedy, Google invented this idea, right? So I was just like, we're very curious about this. So both obviously come back to that my final point is both HTTP2 and RabbitMQ suffer from a very severe problem, which is the TCP. It's a problem with the TCP itself, right? And the problem with TCP is like if you send a packet and the packet is damaged or haven't received by the server and there's no acknowledgement, and that's a packet, right? It's just a packet. The client always retransmit that packet back, right? And that causes any other requests, packets that you are about to send to have wait for an acknowledgement to be received from the server. This is at the packet level, guys. This is not at the stream level. So that means if stream 1 technically didn't receive an acknowledgement, stream 2 cannot even be fired to the server, which is very bad, right? That's a problem with TCP. That's a very, and that problem carries with RabbitMQ. It's a very similar problem, and that's why, guys, Quick was invented. So you know what? We cannot rely on the idea of retransmission to put it at that lower level of our architecture.
you cannot implement that at the lower level. So what they said is that we're not gonna use TCP for retransmission. We're gonna use the bare bone UDP, which doesn't have any of this feature. It just sends a request and relies on the higher level of application to actually does that retransmission and verification of the packets, and that's what Quick did. Quick re-implemented TCP by the higher level, and they built in stream in it. So now you can use one logical connection. There are no connections in UDP, so they created kind of a similar logical connection. And now you can send as many requests as you want, and they are tagged with the stream ID. And if one stream had a bug in it, I don't know, the packet didn't receive correctly, that the Quick client will only retransmit that. It will not stop the rest of the streams, right? All the channels, if you want to call them, right? The rest of the stuff will just go normally, right? Because they have nothing to do with the first one. Because if the stream 2 is good, or stream 3 is good, and stream 1 is bad, why do you have them to suffer, right? Like what HTTP does today, right? HTTP 2, if stream 1 is bad, or has a, I don't know, it was transferred in the ocean, and the fiber was caught, right? The stream 1 will suffer, and stream 2 and stream 3 or stream 5, all the streams will suffer. So you will feel the slowness with HTTP 2. That's the problem with this, right? So Quick solves this problem very elegantly at that level. And now HTTP 3 is built as a very thin layer on top of Quick that uses all these protocols. That brings me back to my final point is like, I think most message queues, right, and databases and protocols should start using queues, to be honest, right? Because that solves a huge problem with TCP. TCP had this problem with retransmission and the packets, right? And now sending concurrent requests at the same time, and that just magnificently Quick solves this problem for you, right? Today I just wanted to talk about RabbitMQ and the idea of channels, and then HTTP2, and then how both of these are having this problem now solves with Quick, and Quick have their own problem. I'm not going to discuss in this channel, but definitely I'm going to make a video dedicated for Quick. But I was very interested to know that the similarities between RabbitMQ as its own from scratch protocol building with the channels, very similar to the HTTP2 protocol. All right, guys, I'm gonna see you in the next one. Leave a like if you like this video, subscribe, and what do you guys think? What is the future protocol? Do you think Quick will hold to its glory and it's gonna become really well-known protocol that is used everywhere? Because I have a good feeling in the next 10 years, Quick was going to
invest in Quick now.
There's one problem that I'm not going to mention here. Is essentially the UDP and how the internet treats UDP. But that's for another video. Like this video if you like it. I'm going to see you in the next one. You guys stay awesome.
Oh, Wireshark. Whoa, let's go.
What's going on, guys? My name is Hussein and welcome to another episode of Wireshark them all. And today we're gonna Wireshark RabbitMQ. So we made a video about RabbitMQ, guys. Check out that course discussing this tech, discussing this beautiful message queue that uses the advanced message queue protocol. And as we did with the previous episode with Wireshark, we're gonna establish a connection between a client, which is this NodeJS application that connects to an advanced message queue protocol server, which is a RabbitMQ server in this instance that I spun up in a cloud-based architecture. And I'm gonna make another video showing you how I did that. It was literally 2 clicks. I love this stuff, and the reason I needed to do that because I cannot run RabbitMQ locally on my Mac and run Wireshark at the same machine, because I won't capture those packets, right? And yeah, so how about we jump into it, guys? So here's what I have. I have a RabbitMQ server running on the...
What? Why can't you capture... Huh? Can't you capture and loop back What? How is it then not transferred over? Then it is. What? Huh? What am I not getting here? How is it not possible to capture a locally running RabbitMQ server? I don't get it.
Cloud. And this piece of application literally connects, creates a channel, and I described in that video what is the difference between a connection and a channel, right? It's like in HTTP2, you have the connection and streams, very, very similar, right? And then I'm not sure who came up with this idea first. So yeah, similar like even SSH, same thing, right? There are the idea of connection and channel, so we can allow multiplexing essentially. All right, so the channel, and then what we do here is we create a channel, and then immediately in this channel we create a queue, and then we send a job to the queue, and this is basically whatever we pass in the buffer. I'm gonna say hi, for example, and that's it. And just we print something, and then immediately we close the channel, we close the connection, and I'm gonna capture the whole thing, right? How about we jump into it? So create a brand new terminal, do node publisher.js, that's the file, and the source code will be available, guys, for you. I'm gonna say hi. Boom. Raise it up. Just prints it and immediately quits. So let's go to Wireshark and see what we captured. Here's Wireshark, guys. And I did a filter just so I can only filter between my server, my IP address client, and the server, which is that's the wherever this thing is. I just pinged the host and then got the IP address and literally filtered the event. So let's go through all this garbage. Let's see if we can explain all that stuff, guys. How about we do that? First, 3 things, guys. We know what this is, right? This is the client is start with 10 and the server is 72, just for simplicity. We know what these 3 things are, right? Send, SYNAC, ACK. That's the 3-way handshake to establish a TCP connection. That's just to prove that RabbitMQ uses TCP, and that's not bad. That's just something we need to be aware of. So that's the 3-way handshake to establish the TCP connection, right? Then we know that send, SYNAC, MAC. And here's the first content that the client sends. Protocol header says, hey, since the RabbitMQ uses the advanced message queue protocol, the first thing it sends is, hey, I'm using the advanced message queue protocol, right? And this is my minimum version, this is my maximum version. Version 1.9, whatever, right? 0.9 actually, right? That's the version of the AMQP, 091, right? And the server acknowledges that packet, and then once we acknowledge that packet, it says, okay, I got your request, and now I think we're good. Let's establish a logical connection, and that's look who's initiating this. It's very interesting, guys, right? That was, I believe, a result of the connection when we created the connection, right? The first thing. But the server responds like, okay, I'm ready to establish the connection for you, right? So now it establishes, it's just to us at that level, it's just a bunch of data, well, to the TCP stack. But we're sending connection to start, and look at how beautiful this thing is. Wireshark actually shows us this stuff. It actually doesn't decrypt, it's already plain text. I'm not using any encryption here. So it knows, it says, hey, this is the version, this is the capabilities, and that's all the things I support, and here, let's start the connection. And the client acknowledges that request, that packet, and then the client now sends its version of connection start. Okay, I'm happy with everything you did, server. Here's the things I support. Here's my configuration, and let's go ahead and establish a connection, right? So technically, if you think about it, we have a TCP connection, but this is the logical advanced message queue protocol that RabbitMQ uses to establish a logical connection on top of the physical TCP connection.
How did you survive that skeleton?
Let's tune things a little bit, right? And you might say, why do we need to tune if can we do the tuning in this? That's kind of optimization that the advanced message queue can do, I guess. But for some reason, we're doing it in another step, but sure. So I'm doing a tuning, and here's the thing. Channel maximum, right? The server says, I only support 200 channels, and that's a good idea for a cloud application, because they don't want to make it in like 1,000 channels, otherwise they need the free. I'm using the free tier, right? And this is the maximum frame size. Each frame that you send, that's the maximum I can support. And here's the heartbeats. Like, we're gonna ping each other every 120 seconds to see if we are alive or not, right? So that's the thing. So the client acknowledges that packet, that connection tune, and then the client sends back connection tune okay. And here's the thing. The client agreed on the 200, the client agreed on the heartbeat, but it didn't agree on the frame max. It says, okay, dude, your frame max is so big, son, I'm gonna only send you 496. That's the only thing I support. Also, awesome. So that server says, acknowledges that, and now we're actually opening the connection. See, we didn't even start this thing yet. So we're opening the connection, and this thing is like, look at this. This is now the client actually opening the connection. That was just starting the connection. Now we're actually opening the connection to send data. We acknowledge, the server acknowledges that connection open. And then the server sends back a connection open okay. So if we get any errors, we will see these errors. And yeah, it even sends back non-hosts. If it's null, I guess that's the only host that supports it, in case if you want to do like a load balancing or stuff like that. Client acknowledge that. Now, channel open. Let's look at the code. We're right here, guys, now. All of that stuff was here, right? Now we're here, okay? Line 13. Look at that stuff. Now the client opens a channel, and the channel, what is a channel? This is like a strip in a connection that we allow basically multiplexing, right? So we can have multiple threads in the same process, sending in parallel multiple packets on the same TCP connection, right? So this is a great idea, and people have been doing it for years. Retransmission, something happened here, apparently. The client retransmitted some packet that had been lost, or because either we didn't get an acknowledgement or something bad happened, right? So let's send back, and the server replies with channel open. Let's go ahead and open that connection. And we don't have a channel ID for some reason, right? And yeah, looks like I have not specified a channel ID. I have an option if I want to I believe to specify a channel ID, huh? Maybe not. I remember there was like an idea to specify a channel ID, but it looks like there isn't. Never mind. Acknowledgement from the client that we received the channel open. And here's the thing, guys. We're declaring a queue. Now the client is about to create a new queue. That's the queue, right? This is it. We're asserting the queue so we can create a new queue on the server. And since I created this before, that queue already exists. So a bunch of retransmission, we're gonna ignore this stuff, right? Because that's what happens when you connect things to the internet. Dupe X, stuff like that. And then we come back, and then here's like, queue declare okay. That's from the server says, okay, I got you. This queue already exists, and go ahead and we have 9 messages in the queue currently, because I used this queue before to do stuff in it. The client acknowledges the queue. And here's the thing, we're gonna publish. Now we are where? We're sending content. We're sending the hi, which is this is 2 letters, right? 2 letters, 2 characters. Right, let's see if this is actually there. In the payload, where's the hi? There you go. I actually sent a JSON. This is number hi. Why is it number hi? Let's see. What did I do? I forgot what I did in code. Oh, look at that.
I'm sending a JSON of message object. Where is this? Oh, there you go. Look at this. I'm sending, I forgot. I wrote this code a long time ago. So it's a JSON object with a number. I'm supposed to be numbers, but for some reason I said hi. Sure, right? So we're sending a JSON, number, and hi. Doesn't matter, guys. You get the idea. Right, so we're sending that, and now we're acknowledging, the server acknowledges that we got the publish, and now, here's the cool thing, guys. The client closes the channel, right? Right here, we're closing the channel. But the server didn't respond with anything, and that's a very, very interesting thing, guys, right? Because when you publish something, and that's one powerful feature in Advanced Message Queue protocol. When we publish, the only thing we need to know that our content has been published to the queue is this puppy, the acknowledgement, and that's it. That's a lower level thing that we don't have control as developers, as programmers, backend engineers. We don't have any control over this thing, right? So it's just, the moment we get the acknowledgement, we know it's in the server. And I don't really care about the reply, because we're publishing a queue. It's going to be at the other end of the consumer to consume that stuff. It's not our job anymore. We close the connection, the server acknowledges the close, the server closes the channel from its side, right? And then the client acknowledges the close, and then what is it? So the client now physically, let's say logically, closes the connection, right? Because you can open and close as many channels as you want while keeping the connection alive, right? You can have many channels in this damn TCP connection. And no, I shouldn't say TCP connection. You can have many channels in this logical connection that is actually just one physical TCP connection. Does that make sense, guys? And then, yeah, we closes this puppy, right? The client says, okay, I'm done even with this connection. Just let's go ahead and close the connection, right? And the server says, okay, here's an interesting thing. This is the delayed beautiful acknowledgement part of this thing. What happened here is, when we closed it, if the server can, instead of acknowledging the close data packet, it waits. Since I'm about to close it anyway, let's wait. Let's not acknowledge that stuff, and let's send you the data with the acknowledgement. So if we look at the acknowledgement, we say, okay, we're acknowledging the same content right here, right? So if you look at this, it should be the next number is 569, and if we look at the acknowledgement, it's also 569. So yeah, we're acknowledging and sending the data. That's the best thing that we can do if possible, and that's where a good, well-written server it shines, really, right? And that's, the backend is written very well. We're acknowledging and sending that data at the same time. If we can do that low-level thing, we'll see great performance. Despite some dupes and stuff like that happen on the internet, we cannot control that, obviously. But what happened here? Where the client acknowledges the close okay, which is this response from the server. And here's the thing, who's initiating the close? The client is initiating the close. Awesome. So the client is initiating the close, right? And look at that, some error happened. Error got reset, right? So far from multiple tests to RabbitMQ, I never seen a clean close of the TCP connection. And I'm not sure why. And we can dig deeper into this thing, and I'm probably gonna need some help from the network engineers, because I don't know why these resets happen. But whenever you see reset, that means something wacky happened in the internet, and the packets went out of order, and we couldn't close the connection in a clean manner, so we reset. So to the client and the server, this is an error. We close the connection in error, despite me just closing it in neatly, to be honest, right? I just immediately opened and closed it, right? And if I look at the code, I also awaited. I made the mistake of, I didn't have these puppies, right? I didn't have awaits. I mistakenly did that. And when you don't do that, since this is asynchronous code, we're gonna do that, and since this is asynchronous, we're gonna send the code and immediately go to the next thing and close the connection. We don't wait for a result from that, right? And then when you do that, bad things happen, man, right? Because you start closing the connection and before actually receiving content from the server, it's gonna be awful. All right, so that's essentially RabbitMQ Wireshark. I hope you enjoyed this video, guys. Give it a like, share it with your friends. I'm gonna see you on the next one. You guys stay awesome. Goodbye. What should our Wireshark next? Let me know in the comment section below. Goodbye.
Oh, he actually made a video with his Kafka. Awesome. I thought that's the end
What
already.
is going on, guys? My name is Hussein, and this is a very interesting article from DoorDash. They're basically a food delivering service here in the US, and they have a very interesting piece of article here. They're moving from RabbitMQ to Apache Kafka. Back-end technologies, two back-end technologies that we discussed in this channel, guys. So check out the RabbitMQ video right here. Also, you can check out the Apache Kafka video right here if you want to learn deep dive, around an hour video detailing both of those decks. So guys, let's be clear about this, guys. That does not mean RabbitMQ is bad, right? Let's be clear about that. And even after I read the article, I still think that is very specific use case to DoorDash that just didn't work with RabbitMQ, right? So the outages being caused with RabbitMQ, I think it has to do with something that I'm going to discuss in this article, right? I'm going to reference the article here. You guys go ahead and read it. I'm going to summarize some of the stuff here. So I'm going to summarize the article, what the DoorDash engineering team did to overcome these problems, and then why did they choose Kafka. They did a great job, guys, detailing the problem, detailing the scalability and availability problem they have, detailing even the solution. They even came up with a proposed different solutions and pros and cons. I like that. The only, if I'm gonna critique this article, is that I'd like to see a little bit more details, technical details that is. Yeah, even that, yeah, I would like to see, I had a lot of questions that I just couldn't find answers for in the article itself, right? And I'm gonna get into these in this video. So guys, DoorDash have a back-end task processing, specifically an asynchronous task processing system. Exactly, that's it. An asynchronous task processing. So we talked about that a little bit, guys. We built one actually. We built one very, very simple one with RabbitMQ, if I remember correctly. And what does that mean, right? What is an asynchronous task processing really mean, right? So that means synchronous versus asynchronous. We talked about these two, guys. What is the difference between these two techniques? Check out this video if you want to learn more about what. Synchronous is that I'm gonna make a request and I'm gonna sit down and wait, right, for the result. And this waiting doesn't have to be blocking necessarily, right? Because I could wait in an event loop, right? I can have an event loop that, okay, I'm waiting for a result, and then a callback to give me the result, but I'm doing my other stuff as well. That's how JavaScript and NodeJS work, right? Even that's the synchronicity word. Asynchronous means I'm gonna make a request and I'm gonna give back a response immediately from the service, from the server, from the backend. But that service is queued. That job, that task is actually not executed immediately, but it is essentially queued to be executed at a later time, right? That's asynchronous
processing here. So let's be very clear about that. Asynchronous in the front end is a little bit different from asynchronous in the back end, right? We're talking about the back end here. It's all back end. We're back end here, right, guys? So if I make an asynchronous job, that means I'm gonna execute a request, and I'm gonna immediately get a response back saying, here's your job ID, come back and check with me later, right? So that's in a nutshell. Doesn't mean this is exactly what's happening here, but that's what an asynchronous system is. And then once the job actually finishes, we write the result back into some sort of place. It could be the same message broker, could be a desk, could be another service, who cares?
Fuck, I knew I forgot something.
And you can do stuff with it, right? So that's what asynchronous task process. And they have tons of this stuff. They have a lot. How much did they say there? There was a number. 900 different asynchronous tasks. Ordering, merchant order, check out. You can imagine, right? All this stuff, you want to get a response back to the user as fast as possible, right? Let's execute a request, get the result, then, okay, I have submitted your order, I am processing it. Go do something else, right? That's how the backend works. Yeah, the backend is executing it, right? Versus synchronicity, where the backend is actually serving you and executing you, and you waiting for it. So here's a technology that I never heard about before, Celery, guys. And you might laugh now because I have never heard of Celery before. So Celery does the job that I talked about here. It's an asynchronous and synchronous task processing software. It has nothing to do with brokers, has nothing to do with messages. It is a software written in Python that you submit task for it, it spins up a thread, executes the task for you, and then gets you back the result. So that it runs, you can either run it in a single node or multiple node, and that's it, right? Celery, and that's one critique that I'm gonna say, that maybe it's well known, that's why they didn't mention this in the article. I wish they talked more about their existing architecture. I felt that they didn't clarify that, to be honest, right? They jumped into the problem, but they didn't draw diagrams of their existing architecture. So if I'm gonna critique it, that will be one critique in this article, right? I'd love to see their existing architecture instead of the problems, right? Make sense? So they have Celery as this asynchronous job executing, but they pull the jobs and all these messages from a broker, because Celery can be actually connected. Actually, let's pull where is Celery? Let's go to Wiki. Yeah. So Celery can be optionally connected to a message broker, and the recommended is RabbitMQ and or Redis, right? Because Redis have this pub subsystem, right? RabbitMQ is also there. They are not supporting Kafka, as far as we learned from this article. Beautiful article, guys. Beautiful. Good job, Saba and Ashwan. Good job, guys. So this is the kind of architecture. Celery as this task execution system written in Python, and then RabbitMQ as the back end that basically submits, acts like a queue, basically. The message broker that submits to the exchange and then writes to the queue, and then a Celery agent, a Celery worker will pick up a new job, will pick up a new task from RabbitMQ and start processing this stuff. So they're using Celery as the vehicle, right? For the longest time, I didn't think, and I still believe we don't really need that extra layer, right? I would have built this myself if I were right. And I built a task manager before, right, in my career. So I would basically use a queue. I'm still looking for a simple queue that does only a queue, right? I couldn't find one yet. RabbitMQ's, I had my little bit of critique, let's say for RabbitMQ, if you know this channel, I talked about what RabbitMQ. I like this architecture, but I think they went too far, right? They started with being a queue, but then moved to a pub subsystem, right? Kafka started as a streaming pub subsystem, and that's the good thing, right? RabbitMQ is trying to do so much. They're trying to expand. When you try to expand, you don't have focus anymore, right? And that your software becomes a little bit complex, and it suffers. I feel MongoDB is headed the same route, in my opinion. I know some of you like MongoDB and NoSQL. I have nothing against those, right? But I just think if you're starting with NoSQL and you are NoSQL and you're schemaless, then trying to expand to become relational is a little bit weird, right? You're trying to solve different problem. Now you're trying just to steal, to eat from the market share from the relational, right? So that's why MongoDB is, I know I'm going off the road, but I'm just talking about RabbitMQ. It's the same sauce, it's the same problem that I have with these systems, right? MongoDB now started supporting full ACID transactions. Why? Right? Just because people were complaining that, oh, I will not move to Mongo because it's not relational, right? If it's not transactional. So they built in transactions on this. And they have some other problems like limiting the transactions and stuff because of that, right? I think they're headed in the wrong direction, if you ask me, MongoDB. But still, it's a great database. The engineers behind it are so smart, solving extremely hard problems. They're solving transaction across shard, which is nuts, right? This is nuts. It's a very difficult problem to solve. But my point with RabbitMQ is the same, right? RabbitMQ is, from the name, it's a message queue, but it does so much other stuff. What is these exchanges and stuff, right? Awkward. But regardless, doesn't mean RabbitMQ is bad. It's just my opinion, and you can have your own opinion. So Celery and RabbitMQ are two systems. And what happens if you include too many systems, guys? Right? Complexity, right? This is not a system written by you. It's an open source, yeah, but you have dependency on this. You have dependency on this. And this is what happened. This is what causes the problems. They started to see a spike, and you can read this article, a spike on RabbitMQ. RabbitMQ will just go down because it will hit a limitation in RabbitMQ, and it's called high surge churn, excessive connection churn. They will hit this. Excessive connection churn, guys. Let's read this. This is what they hit, the DoorDash team. What happened is that they will get a lot of orders, a lot of these execution, and Celery jobs will just skyrocket, and it will start shoving lots of jobs to RabbitMQ and execute, not just publishing, consuming and publishing, both, right? And RabbitMQ hit this, high connection churn. Let's read this a little bit. Let me zoom so you can read it clearly. A system is said to have high connection churn when its rate of newly opened connection is consistently high, and its rate of closed connection is also consistently high. What do we know on the back end, guys? Why did we build HTTP 1.1? Because HTTP 1.0 had the same problem. HTTP 1.0, we're trying to be so precious, saving our precious memory. So we said every request opens the connection and sends the request and then closes the connection. We regretted this decision immediately because it was a bad idea. Opening and closing connection is bad. It looks like, from what I thought, and it's not clear, Celery is the cause of this thing. Celery is every time you want to connect to the RabbitMQ, they open a new TCP connection, which we talked about, and then they send the request, and then they close it.
Oh my gosh, I don't have...
Resulting in a churn of closing and opening, closing and opening. You shouldn't be opening and closing connections, in my opinion. Keep them alive.
I have to
Why
do...
do you have HTTP 1.1? HTTP 2?
What the fuck?
Keep those dead. Keep them running.
confusing existing software and not building your own. And I'm not saying don't use existing software, of course, but and again, I don't know if this salary is the all. I never used it, but it seems like it from the description here, from what I'm reading. And guys, if anyone from DoorDash here and I say anything that is dumb or incorrect, correct me, guys. I'd love to learn more.
Somebody's wrong on the internet.
I'm starving. I need to learn more. Is salary? I need to know what is the architecture between salary and RabbitMQ here.
Well, rabbits
Why
like
are we
celery.
so chatty when it
That's
comes to that?
that's why.
Because RabbitMQ connections are not cheap. They are
But they
very
prefer carrots, so
similar to HTTP2.
we're new.
very
Oh
similar.
my gosh.
And we know.
We need a new technology that replaces celery, and it's called carrot. What do you say? What do you say? Funny? Yes. Big
How
funny.
expensive HTTP2 when it comes to CPU usage, right? We know that. Because all these streams, which RabbitMQ have, called channels, right? All these channels are in the same TCP connection. So
Let's get
RabbitMQ,
rich.
I loved that in RabbitMQ. I love their design. And I don't know who came up with this idea first, RabbitMQ as the advanced message queue protocol, or HTTP2 from Speedy Google. I don't know who came up with this stream or channel. I prefer the word channel over stream. I hate the word stream in HTTP2. I don't like it one bit. I think it doesn't have anything to do with stream. It's a channel. I love the word channel. It's more clear if you tell me it's channel. It's called channel in SSH. It's called channel RabbitMQ. Speedy decided to call it stream. Okay. All right, so I think that's what caused basically the problem. And you have huge churn in RabbitMQ causes what? It causes downtime. It causes basically you cannot accept more. Because the single master, we can't say master anymore.
Oh my gosh.
Node in RabbitMQ is busy doing closing and
jumping on
opening
that
connection,
train.
which is extremely expensive. And I bet it's even more expensive in case of RabbitMQ because they have the logical connection idea of channel. So I bet that's even made the problem even worse. So yeah, availability, scalability. So they clarify these problems in details, talk about all that stuff. They're using Python, which is not a bad idea. I think it's just any language will run into the same problem if you ask me. And
Well, Python is slow.
here's another thing, guys. Here's another thing. I forgot to mention. So salary, we about that. Sudden burst of traffic would leave RabbitMQ in a downgraded state where task consumption was significantly lower than exception. In our experience, this could only be resolved with a RabbitMQ bounce. Wow, that's just unacceptable. RabbitMQ has a concept of flow control where it will reduce the speed of connections which are published too quickly so that queues can keep up. Flow control wise, it's a very similar concept in TCP. TCP have flow control. Quick, that's quick. I believe they built the flow control concept in Quick. Yes. So RabbitMQ also implement an application level flow control. Which makes sense. You don't want to shove thousands and thousands of packets all at once, right? You need to taste the network, see if it, just like TCP slow start, which we talked about right here, this is very similar, I believe, right? Which I never knew that RabbitMQ had a flow control. Kudos, I love it. So yeah, so that's why it is a, what's the English word for it? Double-edged sword. Yes, it's a double-edged sword. So it could hurt and it's beneficial. Network latencies, yeah, but it will kill the system otherwise. So they talk about all this stuff here, consumers, the salary consumers to Kafka and RabbitMQ. We don't talk about Kafka here. So all this stuff, they propose so many other solutions, and they say, okay, let's switch up, since salary supports Redis, let's switch up Redis instead of RabbitMQ. I don't know if that will help. Maybe it will, because what does Redis use? Redis uses the REST protocol, right? Their own custom one. I have no idea they're using channels, So maybe if Celery is doing the same thing, closing and opening connection with every single request and consumption, then I think you're gonna have the same problem, right? That's what they call the hierarchy. That's the closing and reopening hierarchy connection churn. Does not significantly degrade Redis performance. Okay, all right. So they actually tested this thing. Oh, okay. So they said that the closing and connection churn is not a problem in Redis. Probably because it's not the the advanced message queue protocol in RabbitMQ is different than Redis, right? It's a completely different protocol, so then maybe it's a little bit more lenient. But to me, I would solve the root problem. Why do we have this churn of connections? You open a connection, opening a connection is so expensive. Opening a connection is so expensive, especially if it's TCP. What other connections do we have? I mean, Quick, we don't have that yet. But yeah, opening a TCP connection is so expensive. Guys, three-way handshake. And then, they didn't mention if it's TLS or not, but yeah, if you have TLS on top of that, if you have TLS 1.2, sheesh. I bet it's secured. They didn't mention anything about TLS, did they? Nope. See, this is what I crave. I crave information, guys. Guys, I crave information. I need more information. There is not enough details here. So yeah, look at it. Is the architecture between Celery and RabbitMQ, is this secure? Doesn't mention, because if it's secure, this will compound the problem even worse. And if it's TLS 1.2, it's even worse than that. Because we have like what? 2 round trips, plus the handshake, and then you close it. That's why we need to understand how backend works, guys. I keep saying this in this channel. I keep saying it. Fundamentals, guys. Fundamentals, not tools. Do not use tools. And obviously I'm talking to my community here. I don't know DoorDash engineering per se. But yeah, fundamentals is so important. Forget about all these tools. Once you understand how stuff basically works, you're unstoppable. You just understand it. You just need to understand the basic fundamentals. You build this stuff on that. You know what you're using. So they switched to Kafka. And I believe, first of all, they built a smart Python interface on top of their Celery workers so that they kind of canary deploy the thing between RabbitMQ and Kafka, right? Wait a second, I think they removed Celery altogether, did they? Yes. Because you cannot connect Celery directly to Kafka, as far as I know. Right. So they built their own custom system from scratch. Right? That's the MVP. They built it from scratch. It's a custom solution, right? Is that what I read? Custom. I read the word custom. Custom solution. There you go. They built their own custom solution. Again, guys, correct me if I said anything wrong with that, right? So even that custom solution, they still had a problem with Kafka, guys. Right? So before we go to the problem with Kafka, they started just canary deploy between Kafka and RabbitMQ. They shifted all the load from RabbitMQ to Kafka. I'd like to see how did the system behave without Kafka and the custom solution, Celery out of the way. How did that behave? Did they try that? Because I have a strong feeling that Celery is the problem here. I don't know why. Again, guys, I don't know. I don't want to be that guy, but it feels like Celery is the problem here. Custom solution, very thin layer, job processing, and just use RabbitMQ as a broker. I still don't understand why do we need Celery as a software. When was it built? I'm just interested. When was Celery built? Right? It's like, was it before the idea of broker, or was it designed to solve certain problems? I don't know. I know Instagram is Saturday. I read this somewhere here, but I still don't know. Again, guys, I never used salary before, so I don't know. And if any of you guys use salary, that would be interesting to know, right? If you guys have similar problem. But yeah, just because DoorDash moved to Kafka does not mean that Kafka is better than RabbitMQ. Kafka's way feature-wise better than RabbitMQ. That's for sure. Just because of the design decision, we talked about that.
Okay, I guess that's. Is it enough?
But the design choices of seamless adoption, so they started shifting everything back to Kafka.
I want more
Alright, and
arrows.
they hit some problems. Which is called the head of line blocking problem. And I was surprised when I saw this, like, wow, how can I never thought about that? Because we talked about consumer group in Kafka. Check out the Kafka video, and you can use the YouTube chapters to jump into consumer group to read exactly, you can understand. So, whoa, exactly. You'll understand why this happened. So, consumer group, guys, is the ability to, is Kafka's solution for parallelism. So that you can spin up any number of consumers in a given consumer group, and what will happen here is every consumer will get one partition and one partition only, right? And yeah, so that's the thing. That's the idea of Kafka topic partitioning, right? So that means if you have a consumer that is just a slow consumer, then, and this is a slow message, this consumer is just taking a long time to listen to this message for any reason, right? Then you have to come and like, okay, first of all, if this is slow, then the whole thing is just blocked, right? This is called head of line blocking. We have the same problem with HTTP in pipeline, HTTP 1.1, right? When you send a request, you cannot execute any of the other unless the end request is executed, right? It's just ordered. So that's the same problem here, right? See, the fast messages are okay. Slow messages are the problem. And now we start questioning, why do we have a slow message versus a fast message, right? Why would one order take more to execute than another? They should be identical, right? It's not that. Again, I'm not 100% sure, but an order is an order. If I submit 1,000. If I want 1,000 burgers from In-N-Out versus one, it's an order. Who cares? Yeah, it's not like me not gonna make the burgers, just In-N-Out. So yeah, I'd like to know more about why is a slow message or so. I'd like to know more about that.
So yeah, solving these kind of problems will be interesting. Just very interesting. So yeah, parallelism, and they're going through all that stuff. So they started to break down the consumer and trying to find other solutions. And they're still working into these problems, guys. So I'm gonna leave this to you guys. It's an interesting read, definitely. I'd like to see more and more articles like this written in a very detailed manner. Could be just me, I'd love to see more details in my opinion. Because like as I read, I have more questions. But yeah, it's well written. Good job, guys. I love it. Southern Ashland, excellent job, guys. Excellent. I love it. This is a great article. We need more visibility like this. We need to know real businesses using
Oh shit, there are way too many to kill them all. I need to think of something.
This, technologies are performing, right? Again, guys, I'm just gonna repeat it for the millionth time. Does not mean that Apache Kafka is always the right solution to you. Does not mean RabbitMQ is a bad solution to you. Although most of your comments, guys, on my RabbitMQ video was like, yeah, you're right, RabbitMQ, we moved from RabbitMQ because it was so complex. Again, guys, that RabbitMQ, I used it at my work, and I built, of course, I made a video talking about RabbitMQ, and I made a video talking about Kafka. And Kafka, if you start with Kafka, it's way more, how do I say it? I'm going to say it complex. It's more intertwined compared to RabbitMQ, right? But I came in with RabbitMQ a little bit confused. So there are so many abstractions that kind of, the barrier to entry becomes a little high. And learning RabbitMQ becomes really difficult to the amount of features that it have. And that was my problem with it. Again, I might change my mind. Anything that I said in this channel, I could tomorrow and I could definitely learn something new and say, okay, I was wrong. I'm very happy to be proven wrong in anything I say. Obviously, that's how we learn. We keep learning. Who knows everything? Nobody. Right? We keep learning, guys. All right, what do you think of this article, guys? Have you used Celery? Have you used RabbitMQ? Have you used Apache Kafka? Did you build your own asynchronous task processing at all? Let me know in the comment section below. I'm then see you in the next one. You guys take out. Goodbye.
Is that it? We watched the full 2.5 hours. Okay. Yeah, I can definitely not watch another video. That is too much. So, well, guys, please let me know how I can get rid of these withers. They block my construction plans of building this wall. I don't know. It takes way too long. Well, I can take them off one by one, but it takes a few minutes, and well, that seems to be like a never-ending project. Nice, he's not coming over. Oh, that's efficient. It can stay like that. Did I find the perfect sweet spot for the wither? Oh my gosh, there's another one. There's just too many of them. Come on, I can't aim. What the heck, man? Hello there. Oh gosh. That's the end of my tunnel soon. Oh boy. Please die. Okay, that worked fine. Shouldn't do it again though. Oh my gosh, there's so many. Must be kidding me. I tried it with the TNT, but that didn't work too well. I mean, if I can get them all in one spot and I build this TNT thing up here, well, that's not going to reach it, right? Huh. Anyways, I guess it's time to end the stream, since I'm out of videos and I'm not going to play back another one because I can't fit any more videos in the title. It's so frustrating. I want to kill them all. Anyways, that's never gonna happen, so let me end the stream right here. These bastards. Shit. Anyways, okay, see you in the next advertisement stream. Bye guys. Yo, what the fuck is that mic? What is wrong with my audio? Let me end the stream right here. Well, it's probably that other dude talking that a playback might be not the best audio quality. But hey, let's go. Server version is latest version vanilla always. But yeah, that's that.